The field of generative AI is rapidly evolving. And in this evolving world, what we need to do is cope up with the market standards, cope up with what's happening around us. In 2023, ChatGPT was released, and nowadays everybody knows about ChatGPT. Everybody knows how to write a prompt, everybody knows how to get help from ChatGPT. But can you build your own ChatGPT? Or can you build your own GPT based model for your custom data? And that's where generative AI comes into picture. To get started with, AI is being used by everybody, right? Everybody is aware of AI nowadays. In fact, everybody knows generative AI. But try to understand that there are two differences in the world of AI or generative AI. There are two type of people. One of them is a consumer and one of them is a developer. A consumer is somebody who is basically using AI on a daily basis, maybe using Siri or ChatGPT. Those are consumers. They are using AI tools, they are leveraging AI tools. But developers are developing products, and in this video, I'm going to make you a generative AI developer or a generative AI engineer. And what we need to know to understand each and everything about generative AI. Generative AI has a prerequisite, which is Python for sure. Without learning a language or a programming language, you will not be able to understand generative AI. Apart from that, machine learning and deep learning is not a hard prerequisite, but eventually if you want to plan to find a job as a generative AI engineer, I would recommend people to learn machine learning and deep learning. Because imagine you work in a company as a generative AI engineer and then they give you a machine learning use case. Won't you be offended if you don't know how to solve it, right? So follow the career path, learn machine learning, NLP, deep learning, and then jump into generative AI. That's my recommendation. But in case you are curious to know more about generative AI from scratch, this is the video. In this video, we are going to talk about introduction to natural language processing, which is a hard prerequisite to generative AI, without which generative AI is not recommended. Machine learning and deep learning is not a hard prerequisite, so we have not talked about that. But in bits and pieces, I have also explained some general concepts about machine learning in this video. So in this video, you will be getting introduction to NLP, introduction to transformers. Then we will be talking about encoder only and decoder only architectures. Then we will deep dive into large language models, LangChain models, RAG pipelines, and then vector databases and vector search. Apart from that, I have also given a good comparison on open source models and APIs. And finally, this entire end-to-end generative AI is concluded with a beautiful, beautiful project. Just a disclaimer that this 6 hours content is part of my workshop that I had conducted couple of weeks back, especially in 7th and 8th December. So it's like a recorded session, but I have edited it in a way it could be well understood by you. In case you have any hesitance or any kind of issues in the video, please let me know in the comment section. If you love this video, please also share this video and also leave a comment in this video. That's it. So in this video, I hope you enjoyed this. In case you have any other requirements, let me know in the comment section, and you know how to reach out to me. I have all my social media handles in the description. That's it. See you in the video. So first of all, AI, right? What is AI? AI is artificial intelligence, right? What is natural intelligence? Intelligence that you are inheriting from your parents, right? That is your natural intelligence, what you have. AI is something that you are artificially building that intelligence. Now, there are different areas of research that basically leads to AI. Okay. Now, one of them being machine learning, another being NLP, deep learning. Basically, deep learning comes under machine learning, so I'll not write it. I'll write potentially computer vision. Okay. Robot process automation. So, robot processing, autonomous vehicles. Now, these are all different areas of research that basically leads to AI. So, if you talk about the AI landscape, this is how it looks like. Machine learning is nothing but a research area that leads to AI. Okay. Deep learning is another area, or when it comes to neural networks, it is a part of machine learning. Now, generative AI is comparatively a new field. So basically, AI, machine learning is a part of it, and inside machine learning is deep learning. Inside deep learning is something called as generative AI, right? And over the past 2 years, generative AI has been increasing like anything, right? People have started using generative AI. Either they are developing or they are consuming. There are two things. Okay. In the field of generative AI, there are two things. One is a consumer and one is a developer. Okay. Try to understand the difference between both of them. What is a consumer? Consumer means somebody who is using generative AI on a daily basis. So let's say ChatGPT. Okay. Or okay, this is ChatGPT, right? In Hong Kong, ChatGPT is banned. So I usually use u.com or poe.com. So this is ChatGPT, right? You are using generative AI to get your answers. Let's say, uh, give me a 5 minute script on feature encoding for my YouTube video. Start with a hook and end the script with a question to my audience. Okay. Try to have bullet points in the script. So the moment you're asking this question, you're potentially getting the output, right? Now, this is basically generative AI. Your output is getting generated. Now, imagine what's happening is there is a brain. Okay. So I will write it down as brain. To the brain, you're basically asking a question, right? And what is the question? The question is nothing but a prompt. Okay. So prompt is this thing that you are providing. So in this example, what is the prompt? The prompt is this. Okay. That's my prompt. And the output that you are getting is this thing. Now, this brain is something that is already pre-trained. Imagine I ask you 5 lines about MS Dhoni, right? You'll potentially say MS Dhoni was born in Jharkhand and Ranchi, Jharkhand. He played for India. He was the captain in the winning World Cups of 2007 T20 and 2011 50-50 World Cup. He has captained, Chennai Super Kings and so on, right? This is how a normal human will respond, right? But how are you able to respond that? Because your brain already knows information about Dhoni. So similarly, this brain here is, for an example, here I'm asking ChatGPT, right? So here the brain is ChatGPT. Okay. And what is ChatGPT? ChatGPT is nothing but a model by OpenAI. Internally, it is nothing but GPT models. GPT-4, GPT 3.5. There are different versions of GPT. Now there is GPT-5, right? Which is the latest one in the market. So these different models already have trillions and trillions of data. And what are the data sources? The data sources are immense, right? So the data source is from the web search, from Wikipedia, various articles, various other sources, right? So from all these sources, the data is being trained in this particular model. And when you're asking this question, from this entire data source, the interpretation happens, input is being interpreted, and then you are able to get an answer. So the answer is basically a generated answer. So it's a generated text, right? And that is basically the art of generative AI. Okay. So to learn generative AI, The traditional way is like tomorrow, if you want to become a generative AI engineer, you want to go for generative AI roles, machine learning, deep learning, all these techniques are not needed. Hardcore techniques are not needed. NLP is needed because NLP is the core, right? Python is needed because without Python, you cannot build the chatbots or build the applications, right? So, ML and deep learning, see, somewhat NLP and deep learning is also needed because eventually the models that you are going to train are deep learning models. But your deep learning understanding is not mandatory. That's why I'm telling you that machine learning and deep learning is not needed for generative AI. Okay. But if you are applying for a generative AI role, ML and deep learning is needed. Try to understand what I'm saying. To build a generative AI application, ML and DL is not needed. You can easily build once you have understanding on Python, you have understanding on NLP. But if you want to find a job in the market, ML and DL is needed. Why? Because imagine you are joining a company as a generative AI engineer, right? Okay. You cannot really make sure that the company gives you only generative AI related projects, right? In the future, there could be a project on machine learning, there could be a project on deep learning. And if you say, sir, I don't know, you will be in the risk of getting fired, right? Because the path is something like this. Path of learning generative AI in a better way is always to learn Python, to learn statistics, to learn machine learning, to learn deep learning, to learn NLP, and then comes generative AI. Okay? So this is usually the part to get a job. But to understand, yes, you can skip this part because there is no usage of classification, regression, clustering, these kind of things. There is no need. You can directly leverage the generative AI modules, the generative AI libraries. You can directly use the large language models to create something. I hope that is clear, right? So, in this workshop, what we are going to cover is we will start with introduction to NLP. We will then try to understand the introduction to transformers. Then we will try to understand large language models, RAG pipelines, vector databases. We'll also try to talk about API calls versus open source models and project. So by the end of this workshop, I think the agenda is very clear. Right now, you have zero knowledge on generative AI. By the end of this workshop, you will have a good amount of knowledge on generative AI. Because once you start building a project in generative AI, projects can be replicated. Okay. If you have worked on a particular chatbot, eventually taking that piece of code, you can create multiple projects. It's simply copy paste in most of the projects. In some projects, yes, you have to think and do a different strategy. Okay. So my aim in this workshop is to pass on as much knowledge as possible I can with respect to generative AI. So what is AI is clear. So talking about the distribution of classes, I am trying to aim to finish these two today, which is one of the most important things. Okay. Tomorrow's class, potentially we will be getting into large language models, RAG pipelines, and vector databases. These are the most three important things in generative AI. So potentially we will be trying to complete it in 2 or 2.5 hours. For project, we will have dedicatedly 1 hour. Okay, because 1 hour is even short time. But as this is a 6 hours workshop, we will try to finish as much as possible. If we are not able to, we will try to have tomorrow's session to be like 3.5 or 4 hours. We will see, okay, how it goes. Or in worst case scenarios, if I'm not able to cover some of the topics, we will see. We will try to find another way. If possible, we can take another class. Let's see. I don't know. This is the first time I have introduce this workshop. I feel I can pass on as much information, but let's see. Okay, we'll figure this out. So this is clear. The AI technology landscape, artificial intelligence is basically nothing but something that you achieve. And how do you achieve? Using all of these. These are all areas of researches. Okay, we have machine learning, NLP, robotics, autonomous vehicles, computer vision, translation. See, translation and NLP are very related to each other. So, uh, neural networks, chatbots. Okay, now when you hear AI, think statistical pattern matching. So, as per Oracle, AI has become a catch-all term, right? Right now, everybody is talking about AI, whether they use it or they develop it, whatever they do, they are using AI, right? You go to Instagram, you will see a lot of AI pages. They are leveraging AI and building AI related videos, right? Like Cristiano Ronaldo selling vegetables in Indian market, right? You will see some videos like that. Those people are basically leveraging AI. They are consumers. As I told you, there are two types, right? Consumer and developer. So those people are consumers who are using AI tools and products to kind of automate something. We are not going to be, I mean, we will be consumers for sure, but we are kind of looking towards understanding how to develop these things, right? So we are looking into a curriculum where we can be developers, not consumers. Consumers are non-technical people, right? Okay, you have something to ask, you can ask, but what's happening under the hoods, nobody understands, right? If you go and ask somebody randomly, they will not be able to answer, but you will be able to answer after this workshop. What is happening under the hoods? Okay, so AI is not new. Like generative AI is new, but AI is not new. I studied AI in 2011, and I recently realized that, honestly speaking, AI was one of my subjects in my BTech. It was a short subject in my seventh semester. Like just few years back, 5 6 years back, me and my friend were discussing about AI and all these things, and then I recollected, oh shit, I actually had a chapter, a module on AI long back in 2011. So AI is not new. Data science, AI, these are not new. They are concepts coming from long back. Neural networks comes from 1960s. Okay, they are not new. It's just that it became famous very recently. And generative AI started literally 2 to 2.5 years back, the revolution. But the conceptualization started in 2017, 2018. Okay, we knew, like, we I have already used generative AI like 5 years back or 6 years back, but it was not called as generative AI back then. We were calling it on technical names. Nowadays we are calling it as generative AI. Okay, so AI is not new. It's just that generative AI is new. Predictive AI is not new, right? We use Alexa. What is Alexa? You are telling something, Alexa is responding. So what's happening in Alexa? Alexa or Siri or whatever it is, right? So so let's say Alexa sits here, right? Now this is you. You are asking something. Alexa, how is the weather? Right? And you are basically giving a voice. From this voice, basically what you are doing is data is converted into text. Okay? After the text conversion, internally what happens is there are concepts like word embeddings or vectorization. So textual data is basically converted into numbers. Okay? Now numbers is a very layman's term. Whenever somebody asks you, don't tell numbers unless you're explaining somebody who does not understand anything. But always use this technical term called as vectors. Okay? vectors. We statisticians don't call average, we say mean, right? So we have to stick to these jargons. So we call it as vectors, and this process of converting textual data to vector is called as vectorization. Okay, or simply we call it as word embeddings. Okay, now after these vectors are created, then basically you are calling Alexa. Now Alexa is nothing but a application, a model that simply takes vector data and tries to go through, various sources, websites and various other sources, and it is giving you output. Why people are not able to join? Karthik, are you on the call?
Yeah, I'm on the call.
Okay, I saw your message on WhatsApp.
Oh, I forgot to delete it. Sorry.
Okay, it's okay, no issues. Okay, simple, right? So this is not new. Alexa is not new, right? Siri is not new. It's there since ages, right? Google Maps, various other things. These are not new. Predictive AI is not new. Generative AI is new. So what is generative AI? Generative AI is nothing but generation of text, images, videos, and so on. So if I talk about generative AI is divided into multiple parts, right? One of them is a text generation. One of them is, I would say, audio, video, pictures, or images, right? When it comes to text, examples, ChatGPT, or if you want to create a bot, here you will be able to see multiple options like Cloud A, Cloud, whatever you want to call, you can call Cloud A, or OpenAI, or what else? GPT-4 is OpenAI. Llama is by Meta, Facebook, right? Um, um, I forgot the Alibaba's. It's a very complex name. Alibaba LLM. What is that? Yeah, Quen. So Quen, and then we have Mistral. We have Mixtral. We have Zephyr. Um, we have Gemini. We have Bard. So many things are there, and there are many hundreds and hundreds of Hugging Face transformers based on textual data. And these are all nothing but brains, like trillions and trillions of data being provided. Okay. When it comes to audio and video, yes, there are also some applications like Sora. Sora does video generation. Images, we have DALI. Okay. So these are all generative AI. We'll majorly be focusing on text because audio, video, and images are again similar concepts, but they are again they're not that famous right now. Eventually in next couple of years they will be famous, but right now in industry we are mostly using textual data, textual generation, industry level use cases. So I'll majorly be focusing on textual part. Okay, so how generative AI works, right? First of all, when you're asking a question, so the question was here, right? So this was your question. Now if I ask you what are the most important points here, like from a human point of view, what do you think are the most important uh, points here or context? What is the context? Can somebody write down what will be the context in this? In simple terms, just write down in the chat box. The context is creating a video, right? The context is creating a video on which topic? What is the topic here? What is the topic in this prompt? Feature encoding, right? Simple. The topic is feature encoding. Okay, fine. Topic is fine. What is the format? Format as in which format you are expecting the answer to be. So format here means it's basically a script and it should have bullet points, right? Video is ultimate goal. I'm not talking about video, right? Format is 5-minute script with bullet points, right? So whatever output you should get a script. It should have a hook. So hook is important and a question is important, right? And you should have something in bullet points. Let's check whether we have it or not. So you can see the hook here is, have you wondered how machines understand human language or images? The secret often lies in something called feature encoding, right? This is how usually people start YouTube videos, right? And that is hook. Hook basically helps audience to stick to the video so that the retention is higher, right? And you can see further all the points are in bullet points. So it's intact with what I am asking for. I'm also asking for a question to end the script with a question. Let's see if we have. Yes, there is a question. What encoding methods have you used in your projects and what challenges did you face? Right? So, the better way of asking, like the more context, the more information you give in the prompt, the better output you will get. Right? If you give a prompt like this, give a script idea on feature encoding, it will still give you some ideas, or give a script idea for my channel. Like now, if if somebody asks you this thing, a human to human level information, person A is asking person B, give a script idea for my channel. Who are you? What is your channel on? What is your niche? Are you creating videos on programming or data science or funny videos or comedy videos? What is the context? The context is missing here, right? How big the script you want to be? 10 lines, 20 lines, 50 lines, 100 lines. So a lot of things are missing, right? So even if you ask such question to a simple user, like normal human being, normal human being will also not able to understand, right? What is a script? I mean, how big do you want? What is your channel niche? Many things are missing, right? So if you give such prompt to ChatGPT and you expect ChatGPT to give you a better answer or a better generated answer, then you are highly mistaken. Here if I just simply ask this, the basically here it is giving you some random answer. Now it is still giving me a title related to machine learning. The reason being, it is taking the previous information into his memory history. It knows that this person asked the previous question on feature encoding. That's why it gave me a topic related to feature encoding, which is machine learning, because the historical data was there in his brain. If you ask this same question in a new thread, let's say I'm asking in it here, you will see it will give a complete random answer. It's giving me on voice based classification, SCC, because I'm actually logged in. So it's basically understanding that I have my thesis papers on these topics. That's why it is giving you this. Maybe if you go and check yourself, you will not be able to see the same topics. It will give you some random topics, right? Because here the model is not able to understand the context, and this scenario is called as hallucination, right? You are hallucinating, you don't know. what exactly is the ask. Okay. So coming back to the topic, okay, to learn all these things, yes, some basic prerequisites are needed. That's why we will be learning about some NLP prerequisites and some transformer prerequisites. Okay. Yes, hook is a thing designed to catch people's attention, right? Normally, you see videos, right? People usually start with a shocking one-liner statement, right? Now, if you start your video with hello, thanks, welcome to my channel, the way I start, right? And that's why I don't have good views. People who start with a good hook have good views, right? So yeah, I need to work on my script skills as well, but yeah, it's okay. NLP is a prerequisite. What is NLP? So far, anybody has any questions? If not, I'll proceed. I have just talked about some basic things. I will be covering the art of writing prompt. We will have a prompt engineering session tomorrow. Different types of prompt engineering techniques, everything will be covered. So don't worry about it. In case you have any questions, leave something in the chat box. I will respond. Moving on to NLP. Okay. So NLP is nothing but the idea of transforming free form text into structured data. Okay. So natural language processing. In simple terms, right now I'm talking in English, right? What you are able to understand the way I am talking, right? And that's because you understand English. I understand English, you understand English, so we are able to talk. So imagine in this group, assuming nobody is coming from my state. So if I start talking in Odia, nobody will understand, right? I mean, just ignore the outliers. I see one or two people from Odisha, but imagine, okay, let's say I'm talking in Spanish. You will not be able to understand, right? Why? Because there is a gap of understanding. So similar to how humans interact, machines also need to understand, right? If I say Ram is going, I know Ram is a noun and going is a verb. But how will computers understand? And that is where NLP comes into picture. Computer needs to understand what you are telling, right? Let's say create a 5-line paragraph about MS Dhoni. Okay, this is a simple script or simple paragraph on Mahendra Singh Dhoni. Now imagine, okay, randomly you go and ask somebody from Spain or somebody from the Europe about Mahendra Singh Dhoni, they will not know. Why? Because their brain does not have information about MS Dhoni. If you ask an Indian, of course, you will get the answers. If you ask a cricket lover, they will give you the answer who MS Dhoni is. Why? Because MS Dhoni's information is already in your head. If you ask somebody, if I go and ask my colleague who is a Hong Konger about MS Dhoni, he will not be able to answer because he does not know MS Dhoni, right? So what I'm trying to say is when you work on these kind of models, especially NLP related models, when you're passing the information here, he, who is he? I understand, you understand, he is Mahendra Singh Dhoni. But how will computers understand? So computers need to be understood. And this is where NLP comes into picture. And in order to understand and deal with NLP, there are some prerequisites. Okay. First of all, what are the applications of NLP? NLP applications are language translation. Okay. You go to Google. Uh, so detected as Spanish, you are able to translate it into English. How are you? Right? I'm fine. Now, how is Google Translate able to respond back? Because Google Translate already has information about all the languages. Thousands and thousands of people are already using Google Translate on a daily basis. So all the translations is being fed to that memory, that brain. So tomorrow, or you're going and asking something, how are you? It is able to answer because it has been trained with multiple languages. But forget about Google Translate. Imagine we are creating our own thing. Let's say my translation, Sat Translate, okay, or Satyajit Translate. I'm creating my new tool. Today, I have all the information about English and potentially Hindi. I don't have any other languages. So if I ask how are you, of course I will be able to translate it in Hindi. आप कैसे हो, right? But if I ask in Telugu or Spanish or French, it will not be able to answer because my model does not have that information, right? So information is needed. So language translation, one of the most important applications of NLP. Chatbots. Currently, right now, generative AI is very famous, right? In industry level use cases, in industry level applications, trust me, I have worked on more than 40 proof of concepts in the last 2 years. Some of the applications might already be running on my AWS account. This is an application I did for a French company, 𝐓𝐢𝐻𝐦𝐞𝐋𝐢𝐧𝐞. Let's say I will ask, what is 𝐓𝐢𝐻𝐦𝐞𝐋𝐢𝐧𝐞 sustainability goals? It will be able to answer from some documents, and the document is also visible to you. This is like a chatbot, right? Trust me, right now, especially in the field of generative AI, if you ask me what is that application which is being used most of the times, or most of the companies are using it or doing trials on, are chatbots. So generative AI's major application right now is chatbots. Out of the 40 proof of concepts I have built in my current company, almost 6 or 7 we have productionized. That means we have pushed these models into production in clients production environment. Out of this 6 to 7, except one, everything is a chatbot, because companies are exploring chatbots right now. So one of the most important application of NLP is chatbot. Even one of the most important application of generative AI is also chatbot. So it's a custom chatbot. Chatbot built on your own documents, or chatbot built on your own question and answers document, or chatbot built for your own website. Okay? So there are, I'll talk about multiple generative AI use cases so that you will have understanding. Okay? Another application is text summarization. Okay? I have a there is an online tool. Even we also have, I might show you something. Um, Difficult to show some. So many folders are there. It's okay, forget. So text summarizer, let's say YouTube summarizer. So there was a tool I was using. I think I forgot the tool's name. Let's say we'll use some of these tools. Okay, let's say I'm going to YouTube, and let's say I'm going to my channel, and let's say I'm taking a video. Let's say, okay, let's say I'm sharing this, copy this. So what's happening here is It's simple, right? If I ask you, you will probably be able to explain me. What's happening is I am passing my YouTube link, right? Internally, what's happening is audio is being extracted, okay? And audio data looks like this, right? It's a one dimensional data. Can somebody tell me in this one dimensional data, what is my x axis, what is my y axis? Just guess. If you don't know, it's fine. Don't Google it. In audio data, what is x, what is y? X is time. Sound, it's not sound, but yeah, I mean, see, again, in layman's term, it is sound. But don't talk in layman's term. Yeah, y could be frequency or amplitude. Amplitude is a better. It's not frequency. Sorry, my bad. It's not frequency. It's amplitude. Frequency is nothing but one by t, right? The formula of frequency. So this is amplitude. Okay. Okay. Forget about it. YouTube. When I am passing the link, I'll show you that tool also. What happened? Okay, it seems to be a scammy tool. They will ask for payment and all those things. Forget about it. Now, what's happening is when I'm passing the YouTube URL, I have a project on this. I'll not be able to show it tomorrow, or let's see if I have time, I can show you. Um, but I cannot do a walkthrough because I can do walkthrough only on one project. If you tell this one, we can do a walkthrough on this one, but I have another project on mind as well. So you're extracting audio. From audio, you're extracting text, right? And then, so the text is huge, huge text, right? Because from my 10 minutes video, I could have spoken like 500 lines, right? And this is where an application of NLP or transformers comes into picture, and then you are able to get all the important information. Okay, so let's say it's something like this. Let's say I'm taking information about Sachin Tendulkar. Can you summarize in 5 lines? So here I'm directly using generative AI and I am able to get the final outcome, right? So here exactly that is happening. You are getting the final generated output or summarized output. Just to show you guys, I have used ChatGPT. So I have used a transformer. ChatGPT is nothing but a transformer, okay? But as I told you, without generative AI also, with traditional NLP techniques, you will also be able to summarize it. Okay, it might not be the best output, but you will still be able to do it, right? Before generative AI, we were using NLP. Now, yes, we have generative AI, so we are directly going and using generative AI and getting the output. Things are a little bit easier these days because of generative AI, right? So, but this is how the flow is. Okay, so very important. Sentiment analysis. What is sentiment analysis? Reviews and all those things. Can you unmute and ask what do you mean? What's the difference?
What
Are
is
you?
the difference between this NLP and transformer then?
Yeah, yeah. So NLP is like, just imagine it as a 10-year-old boy. Okay, and transformers, imagine it as a 20-year-old boy, more matured, more data is already, it already is trained on a multiple data. So this is like a pre-trained model, more matured model. That's why it is able to give you better output. Okay, so NLP are traditional techniques. Before the generative AI came into picture, we were all using natural language processing, you know, some old transformer models like BERT models and all those things. But now we have generative AI, right? That's why people have forgotten all those things. But as a core concept, it's needed. You need to know. That's why I'm teaching you. Okay. Slowly, once we understand various other topics, your understanding will be better. Okay, why generative AI is giving you better results? I'll give you a comparison as well. Speech recognition, yes, good application of NLP, right? Alexa, you're telling something, speech is recognized to text, and then text is being interpreted. Fraud detection can also be done using NLP. Some of the important NLP libraries are NLTK, which is nothing but NLP toolkit. We have Spacey, Text Blob, and various other things. Okay, so first hour has been good. Now the next 1 hour we will be talking more about the NLP concepts. Okay, there are various NLP concepts that you need to understand. So we will be talking about NLP basics. Okay, so what are we going to cover here? I'll give you a brief idea. Firstly, we will be talking about tokenization. Anybody has understanding in my this thing, just let me know. Okay, so instead of writing I can use text box. After tokenization we will be understanding some concepts about stemming and lemmatization. Stemming and lemmatization. Okay, then we will talk about stop word removal. um Limitation, stop word removal. Yes. Then talk comes the most important thing, which is vectorization. Somehow, number 4 point and number 5 point are very similar to each other. We will talk more about word embeddings. Okay. Now, these three are nothing but pre processing steps. In machine learning, people who knows machine learning, you do data cleaning, right? Initially your data is not clean, right? There must be missing values, there must be some redundant columns, there must be some n number of issues, and you are eventually solving those issues so that you can have a clean data for your model building purpose. And that's exactly what is called as pre-processing steps, right? So in NLP, these are the few pre-processing steps. We will be talking about this. And of course, in word embeddings, we will go quite in depth. Word embeddings are majorly of two types. One is a count based, where we will be studying about bag of words. We will be studying about TF-IDF. We will be studying about Glove. I will not cover because we don't have time. So bag of words and TF-IDF I will cover. Glove on a very high level, I will tell you what exactly is Glove. Okay. And another technique is prediction based technique, where you will be studying word to vector. Okay, word to vector also has different flavors, CBOW and skipgrams, but majorly we will be covering word to vector, in general word to vector. Okay, and I think that's it. And then eventually after NLP we will be studying about transformers. Okay, so let's take a quick break, 7 minutes break. Okay, so I hope people are back. Let's move on with the next topics. So the first topic is tokenization. Okay, tokenization. The simple explanation is dividing a particular text, sentence, or paragraph into individual words or sentences. So there can be sentence tokenization, there can be word tokenization. Okay, imagine you have a paragraph of 10 sentences. Sentence tokenization will be, you will have 10 different tokens, 10 different sentence tokens. Word tokenization basically means you are dividing one sentence into multiple words, right? But the idea is very simple. Tokenization important and the fundamental step in NLP. The very first step that we do is tokenization, because only once the tokenization is done, then comes the next steps: stop word removal, lemmatization, stemming, blah blah blah, and then you prepare your data, word embeddings, and then you create your model, right? So first is tokenization. I'll quickly jump into the Jupyter notebook so that, 1 second. Okay. So the first thing is I'm importing NLTK. Then let's say I will start, I'll do it in the same line from NLTK dot tokenize import what tokenize. What else do we need? Um, uh, 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 Send token. Okay. Cannot import name. Send token. Send token or send tokenize. Send tokenize. Send tokenize. My bad. Okay. From NLTK, this is the library. This is the internal method, and these are the different functions that we have, right? Word tokenize and sentence tokenize. So word tokenize basically does the word tokenization, and sent tokenize does the sentence tokenization. Okay, let's say one of my sample text will be, let's say text is equals to NLTK provides powerful tools for tokenization. Okay, this is my sentence. If you want, we can add one more sentence. I'll say also it includes word tokenization and sentence tokenization. Done. That's my text. If you want to print it, you can print it. That's my text, right? Simple string object. The type of txt is string. Simple. Now, if you want to do a word tokenization, simply what I will do is I will just pass word tokenize and I will pass txt. That's it. You see, we are able to get all the tokens. NLTK provides powerful tools for tokenization. Right? Now, let's say I have a text 2, which is boy is good, girl is good, both boys and girls are good. Okay. Now, in this, you can see boy is good, girl is good. See, comma is also coming as one of the tokens, right? So, but this is a mistake. I mean, this is not good, right? Because you cannot really pass comma to a model or is to a model, because these are very very common words, right? We'll talk about stop word removal later, but yeah, this is the simple concept of tokenization. Let me delete it. We'll take the just one example of txt. Similar to word tokenization, what I will do is I will do sentence tokenization. So instead of word, I will just use sentence tokenization, and you see that there are two tokens, which is sentence 1 and sentence 2. Okay. Jumping back to the next topic, tokenization is understood. Next topic is stop words removal. Very important topic, because very generic and important topic. Okay. First of all, try to understand what are stop words. Stop words are commonly used words in a language. Okay. Why stop words removal is important? We need to see, first of all, stop words. What are stop words? Let me give you first examples. Okay. Some of the stop words are, where is my Miro board? Yeah. Some of the stop words are the, is, are, a, all these are stop words. Okay, I am, and we need to remove all these stop words. Why? What do you think? Give me an answer. What do you think? Why we need to remove all this? Imagine you are working on 5 sentences, right? The is potentially present like 5 or 6 times. Is present around 15 times. A is present around 18 times. So why do we have to remove these from the corpus or from the original data? The reason is very simple, because these are very common words. It needs to be filtered out during the processing, because it's not important, right? The is not important, is not important, are is not important. They don't provide any context. There is no meaning. I mean, there is potentially meaning, but you can ignore it. So stop word removal is very, very important. Okay. So again, we will jump into practicals directly on how stop word removals can be done. Basics of NLP. I'll potentially make it stop word removal. Yes, no, it's not noise. Um, it's yeah, you can call it as noise. Okay, so let's try to talk about stop word removal. NLTK is already imported, but I'm just doing a good practice because initially I thought of creating different workbooks, but as these are short lectures, I'm using the same one. That's why I'm just importing again. Okay. In case you want to divide this into different notebooks, you can divide it. So from NLTK, I'll be using a corpus stop words. So stop words basically, 1 second. So NLTK library already has a corpus of stop words. So we can check NLTK stop words list. So NLTK is a library, right? Somebody has created this library and they have already created this corpus. And this corpus is of 127 words, right? What are the stop words? Myself, my, we, our, ourselves, you, yours, blah, 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 right? These are unnecessary keywords. So I'm just importing that particular stop words function, and I'm also importing word tokenize. Okay. And let's say I will use input sentence. Let's say sentence is equals to, this is a sample sentence showing off the stop words filtration. Okay. This is my input sentence. Okay. So first of all, tokenize the sentence. Um, corpus stop words. Okay, let's try. Let's say I'm saving it in a new variable, words equals to word tokenize and pass sentence. And let's say I want to print my words, and this is how it is. This is a sample sentence showing off the stop words filtration. Right now, mm, okay, how do we filter out stop words? Let's say filter out stop words. New sentence is equals to we can also do okay. Before this, let me do this thing. Um, so there is another concept called as case holding. Okay, so I'm just making it to lowercase so that basically I'm normalizing it. Okay, and then I am tokenizing it. So now my token is everything is of lowercase. Okay, so all these high uppercase I have converted into lowercase. So um, word for word in words. Um, if word not in stop words dot words, um, I'm not sure. Let's say okay. Filter out the stop words. Okay, so the comma is not gone because comma is not a stop word. As you can see that NLTK stop words list. In this list, there is no comma, right? There are only certain keywords like this. But eventually you need to remove the comma and special characters. So all these things, there will be another step of removal of special characters. But that is not a part of stop word removal. That is a part of pre-processing step, but it's not a stop word, right? It's just you are getting rid of unnecessary characters, right? But here, what is a stop word? This is a stop word. You can see this is here. Where is this? This is here. So this is a stop word. Is a stop word? A is a stop word. These three are stop words. And what else? Sample sentence showing stop words filtration. Anything else is a stop word. So if you want to check all your stop words, this is a of the. These are the five stop words. Off is off a stop word. Yeah, off is also a stop word. They have written down off as well. Okay. Anyways, right? So this is how your stop word removal is done. I'm just showing you different steps, and then eventually when you start solving a natural language processing based problem statement, let's say text classification or sentiment analysis, I will show you how each of these steps are used, and then we will try to create a simple model. Okay, in NLP also, I'm going to create a simple model. So that can also be a very, very small project, but yeah, I mean the complexity will not be too much, but still it will be a small project. Now next topic is going to be stemming and lemmatization. Stemming and lemmatization. Okay, so what is stemming and what is lemmatization? Try to understand both of these. Both of these are similar techniques. Okay, they basically reduce the number of words to their base level or root level. Okay, let me write down: removing or basically reducing words to their root level. Now you must be thinking, what does this mean, right? Okay, so big, bigger, biggest. They are eventually a form of different words, right? Like they are just form of big, right? How big it is, it could be bigger, it could be biggest. But eventually the root word is big, right? Similarly, run, running. Eventually the root word is run, right? So stemming and limitation basically helps you to convert all these form of data into their root form. Okay, stemming and limitation are, they both do the same technique, I mean the same goal, but they are different. Stemming is different, limitation is different. Stemming has some flaws, limitation has some pros and cons. Stemming also has some pros and cons. Okay, there is a question: what would be correct sequence of operations to be done? Would changing the order have an impact? Okay, I'll talk about it. Okay, okay, understood. Converting it into a root form. So in simple terms, what is stemming? Stemming is, let's say some examples are, let's say running or runner or run. It basically converts it into run. Programming converts into program. Okay, stemming is a simple process. It basically removes the suffix without considering the context. That is stemming. Okay, now you must be thinking, can we have some examples where stemming fails? Yes, there are many examples where stemming fails. When does it fail? Happiness, happy. Universal or university, interpreted as universe or maybe universe. Okay. Similarly, fishing, fished will be fish, right? Now, when you do these kind of things, fishing is different, fished is different, right? Universal is different, university is different. So when you are using stemming, you are converting it into original format, right? And in the original format, happy does not even exist. Not not an not a dictionary word. Universe or universe, from universal or university, it's universe, right? So the context meaning will also change, right? Fishing and fished changed into fish. So context is changing. Similarly, what is limitation? I'll answer your question, Harsha. What is limitation? Limitation, the core concept behind limitation is also similar to stemming. It also converts any word into its root form, but it is a more sophisticated process. It basically considers context. Like stemming does not consider, but limitation considers context. So limitation is a better step. Okay. One of the examples of limitation is good, better, best are all form of good. If you pass these three keywords into stemming, it will not be able to answer. But limitation is able to answer. But what are the, so running will be run. So what are the demerits of limitation? When does it fail? When does it fail? One very good example is saw. Saw is interpreted as see. Saw means whatever you have seen, right? It could also be a tool, right? But eventually, whatever you have seen or a tool is misinterpreted as see. So, limitation fails. Okay? Went, go. In some context, you have used went. That means he has already gone. But now you're using go. So, contextual meaning is different, right? It could be misleading. Understood what is stemming and limitation? Now, a very good question in the chat is why all these steps are required. What do you think? Anybody in the chat? What do you think? Why these two processes are needed? See, tokenization understood. We need to break down the text. Stop word removals understood. Makes no sense to use stop words, so we will get rid of it. But why stemming and limitation? Why can't we use the raw data? Any anything to say? See, basically what happens is when you, so first of all, you are cutting down the data from 1 million words to, yes, exactly. Diptarshi has told the right answer. Reducing the dimensions of data. Imagine you have a corpus of 1 million, 1 million words. You can eventually cut down into, let's say, zero point 0.4 million, right? Or maybe 0.2 million, I don't know. So eventually, reduction of data is very important. Secondly, it improves the information retrieval and the processing efficiency is also increased. Okay, so that's why it's basically one of the data processing step. Now you might be thinking, okay, why not 1 million? Why 0.4 million? Latency, right? Imagine your computer is a 8 GB machine, your laptop, and you are running a 5 GB game. It will be slow. If you run a 1 GB game, it will be faster as compared to 5 GB, right? Same concept. If you have more data, the processing time will be more, everything will be more, latency will be high. So it's always better to reduce. So that's why, as a pre processing step, we reduce the dimensionality. Understood? So let's go ahead and do a small exercise on stemming and limitation. Now, in stemming, also, there are different types of stemmers. Okay. I will be taking an example of a Porter stemmer. Limitation also has different types of limitation. Um, WordNet lematizer versus uh, types of lematizers. I forgot actually. One of them is a WordNet. What about others? So okay. WordNet. We will be using WordNet. So let's again jump into our notebook. I'll change it to stemming versus lemmatization. Okay, so what we will do is again importing everything NLTK. Now here we will be importing Porter stemmer NLTK. NLTK.stemmer, okay. No module named stemmer. Maybe stem. Okay, stem is working. So let's say we will start with initializing the stemmer. So I will get started. Let's say stemmer is equals to Porter stemmer. Done. Let's say I'm providing some sample words. Words equals to running, run, runner. Let's say happiness, programming. What examples did we take? Running, run, let's say big, bigger, biggest. Okay, these are the different words. Now I will be applying stemming technique. Stemmed keywords or words is nothing but this word stemmer dot stemmer dot stem of word forward stemmer dot stem uh, stemmer dot stem 1 second stemmer dot stem of words 0 run. Basically the first element is run. What about 0 1 2 3? Is it coming? Happy. Okay, so basically stem word for word in words. I think it should be able to get, and then let's say I will just simply print the stemmed words. Oh wow, so running is run, run is run. Okay, runner is my bad, runner is runner, runner is not coming as run. Happiness is happy, programming is program, bigger is bigger. Now what I will do is I will start using lemmatization. Okay, so lemmatization similarly like Porter stemmer, we will be using word net lemmatizer, and again same steps. So initialize the stemmer. Let's say stemmer is nothing but lemmatizer. So my lemmatizer is created. Okay. I'm passing the same words, so nothing to worry about. Applying lemmatization techniques. So lemmatized words. And here I will use lemmatizer dot stem for word in words. Okay, let's try this. Word net lemmatizer. Okay, word. Okay, applying lemmatization technique. Lemmatized words equals to lemmatize. Lemmatize. And then lemmatized words. My bad. So running lemmatization word is running. Run, runner, happiness. Oh, something is wrong. Wait. Um, NLTK.stem, WordNet lemmatizer. Initialize the lemmatizer. WordNet lemmatizer. Um, okay. For runner, running, runner, happiness, programming, bigger. Okay. So let's say I pass a different set of words here. After lemmatizer, let's say I will pass a new set words new, and I will change it here. Let's say I will give some complicated words that we kind of studied. Let's say good, better, best. Let's say nice. Okay. Good, better. Okay, my bad then. I thought good, better, best is considered as good, but in under NLTK it's not. So only mice is having mouse. So my understanding was wrong. Let's give some other words. Let's see whose, geese. Yeah, geese. So basically plural words are getting converted into singular format. Okay. So what we can do is when we are applying these techniques, we can apply stemming and limitation separately, because stemming is good on certain words, limitation is good on certain words, right? And both of these techniques are used to reduce the dimensionalities. As simple as that. Okay. Now, apart from Porter stemmer, there are different other type of stemmers as well. You can explore by yourself. But the idea is very simple and straightforward. Both of these techniques helps you to get into a base form or a root form, right? So just simply go to nltk.stem package and you will potentially be able to get different options, or else simply you can go to ChatGPT and try to leverage. So just ask, give the code for Potter stemmer and ask ChatGPT, this is my code block. Can you also write down the code for different other stemming techniques? Maybe I'll show you how to leverage ChatGPT to help in your journey. ChatGPT works really good when you give an example because it understands the context better. So let's say you are passing this information. Similarly, give code snippets for different other type of stemmers. So it will be able to give you. See, Potter stemmer is there, Lancaster stemmer is there, Snowball stemmer is there, and they are internally different from each other minutely. Okay, but overall concept is same, right? Stemmer and limitation concepts are same. Moving on to the next topic, stemming and limitation. The next topic is n-grams. Another core topic in the NLP basics area is n-grams. And n-grams is majorly of three types. What is n-grams? N-grams preserve the sequential structure of language, aiding in context understanding and feature extraction. Okay, and n-grams. Second. And n-grams majorly are of three types. Okay, one is uni, one is bi, one is tri. Okay, majorly three types. Uni means n is equals to 1. Bi means n is equals to 2. Tri means n is equals to 3. Okay. Now, when you are actually saying something, let's say you are saying something, right? You are giving a speech. Your speech has n number of items, right? Using the n-grams, you will be able to train a better NLP model. Now, I'll give you an example and you will be able to understand the importance of n-grams. Okay. Let's say I'm doing a next word prediction. Okay. So my let's say we will take Sachin Tendulkar's example. Yeah, let's say we'll take this. Okay. This is my data, input data. Okay. How many sentences are there? Sentence one, two sentences, three sentences, four sentences, and five sentences, right? So imagine you are using this particular input for your NLP task, right? And your question is, okay, I'll give you a better example. You might not be able to follow this. How many of you use, everybody uses Gmail, right? Now, in Gmail, when you're writing a mail, right? For example, I'm writing to somebody. Can you see this? The moment I am typing it, I am able to see some recommendation, right? What do you think? What exactly is this? And how this recommendation is coming? Any idea what is coming to your head? What's happening? So understand this thing that Gmail, eventually when you're writing a Gmail, Google might be actually using one of the Google's internal models, right? In order to do this kind of predictions. So let's say, um, I hope everything is well. The moment I am start typing in EVE, I am able to get a prediction, right? So the moment I am typing I hope, I am able to get the prediction. I hope everything is fine. Now, how we are able to get this prediction? So imagine Google has a model, right? And this model is trained on trillions and trillions of data, right? And all of this data, when you are training this particular model, you are dividing the data into n-grams. Now imagine what is n-grams. Let's say Raj is going to the market. 1 n-gram means everything is a gram. 2 n-gram means Raj is going to the the market, right? Similarly like this, imagine there are trillions of data, and from this trillions of data there would be trillions or quadrillions of bigrams, right? So here what's happening is there must be a bigram like this, right? I hope, hope everything, everything is, right? There could be another bigram, right? Hope you, everything fine, right? So there are millions of such bigrams, right? Now, when you are typing in, what's happening is first you are using this from your corpus, and then after hope, you are taking the possibility of the next word's three letters and you check how many bigrams do we have where we have hope and EVE. Let's say one, and let's say there is another one, hope everyone, hope all, everything is something like this, right? So you basically check how many possibilities are there. So there are multiple possibilities, and what is the most probable next word? So you're basically predicting one word, and after that prediction you are predicting the next word, and then the next word, and then the next word, and that is how it is able to give you a prediction. And many other people have also used this particular sentence like millions and millions of times. Okay, and that's how Google is able to predict what could be the next word, right? I hope, let's say here I switch from T to O. I hope everyone is doing well. And you can see when I typed in everyone, there is no recommendation. Maybe there might not be any bigrams where hope everyone and everyone something is present. That's why there is no recommendation. But the moment I'm doing everyone is, I'm able to get a recommendation, right? So in simple terms, when we have large corpus of data, we divide data into n-grams for better understanding and better model building. As simple as that. So it is also treated as one of the pre-processing steps or just a step before creating your final model. And unigrams are used for simple tasks. Bigrams are mostly used for capturing relationship between pairs, and trigrams are used for complex or advanced use cases. But which of this technique is good? Everything is hit and trial. We hit and trial and then we come to a conclusion which is good, which is bad. Okay, so that is your n-grams. We'll quickly go into the next topic because I'm running out of time. The next topic is vectorization. Very important topic. Pay attention. What is vectorization? Okay, let's in simple terms, vectorization is nothing but conversion of textual data into numbers, which we also call it as vectors. Okay. So if I take a simple example, he is a good boy, right? Now this is my sentence one. Okay. The very first thing that I will do is stop word removal. If you don't do stop word removal, you can still be able to do vectorization, no problem, but it is a recommended step. Okay, because if you don't remove stop words unnecessarily, the, is, are, am, all these Words that makes no sense will go to your model, and your model's performance will not be good, right? So imagine you are trying to create a model on cricket, and you have all these random words which has nothing to do with cricket, right? It is just baseless or contextless, so there is no need of adding extra data, right? So stop word removal is important. Now imagine after stop word removal these three words are gone. So now you have good boy. Okay. Another sentence is she is a good girl. Simple. Stop word removal SWR, and then we have good girl, right? If I have to interpret this into a textual into a vector format, good boy will be 110 and good girl will be 101. How? I will explain you. This is where the first vectorization technique comes into picture, which is bag of words. Okay. Now, bag of words means eventually there is a bag, and inside this bag are different words. So, in this entire corpus, how many words are there? Three words. What are they? Good, girl, and boy. Right? Everybody? Yes? So, if I have to draw a matrix, I will first write down good, then I will write down boy, then I will write down girl. Here as a row, I will write down sentence 1 and I will write down sentence 2. Is good present in sentence 1? Yes. Is boy present in sentence 1? Yes. Is girl present in sentence 1? No. Is good present in sentence 2? Yes. Is boy present in sentence 2? No. Is good girl present in sentence 2? Yes. So what is my sentence 1 vector format? 110. What is my sentence 2's vector format? 101. Till now, everybody is clear on how bag of words work? Simplest technique, right? Very simple. Yes? Give me yes. Yes. Hmm. Yes, basically helps me to understand whether you are awake, sleeping, or are you attentive. Okay. Now, 1 second, let me drink some water. Now, the question is this a good technique? Of course not. This is just one technique of vectorization. But is this the best technique? No, for sure not. It has a lot of flaws. One of the flaws that I can explain here is good is present in both the sentences, right? Is there an importance of good? No, because it is present in both the sentences. So it's not important. Imagine you have 100 lines of paragraph, right? Every line you have good, 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 good. It makes no sense, right? Everywhere there is good. So for me, good is not important. If out of 10 lines, one of the lines or two of the lines has good, that makes it more impactful, right? So, bag of words fails on this concept to understand the contextual meaning and the importance of certain words. Somebody is unmuted, please mute. Arpit, I'll mute you. Okay, thanks. So, what are some different vectorization techniques? See, in vectorization and word embeddings, I can potentially take a class for 20 hours. Such a big topic. But we will try to summarize and try to understand the most important things. Okay? So, what are the other vectorization techniques? One of them is TF-IDF. One of them is word to vector. One of them is GLOVE. One of them is fast text. Let's try to understand what is TF-IDF. Okay? Bag of words is understood. Let's move on to TF-IDF. Till now, any doubts? I mean, I'm pretty much sure there will be a bunch of doubts because many things are moving fast, right? If you are not able to ask right now, it's completely fine. We can take questions on the WhatsApp group later. No. Is vectorization and embeddings mean the same? Yes, almost.
Hi,
Yeah.
I have a doubt. So whatever examples you have given, these were like very formal languages. But when we do the analysis of YouTube comments or Twitter words, so sometimes people write words in short, like for because they will simply write BCZ, or sometimes it's in English. So at that time, how do we deal with it?
So if you are dealing with English data, that means your model needs to be trained on English, right? Because even on Google Translate, if you ask in English, it will not be able to understand, right?
Correct.
So whenever you are dealing with English data, imagine in your company, the use case is very focused on English data.
Yes.
So you need to train your model with English data. So let's say you are creating a BERT model. Like imagine your use case is interpreting data or maybe text summarization, right?
Yes.
So uh, eventually it's text summarization, right? So in that case, you can actually create a custom BERT model. I will talk about BERT models in a while. You can create a custom BERT model, but data is very critical here. You need to train your BERT models with huge corpus of English data. Then only your model will be able to understand. Else, it will not be able to understand. So there are some pre-trained models on English data as well. There are some Hugging Face models on English data, but you have to check. I don't remember the names. I can tell you. But there are some models, English to English, right? So there are some models already available. English BERT is also there. Somebody has created, right? Imagine you have a bunch of millions of English records, English data. You can also create your own, custom BERT model and make it public for people to use it. But the core concept is same. If you have data, you can pass it and then you will be able to interpret. Else, if you don't have that, model will not understand, right? BC is because we understand, but models will not understand. So
Yes.
these kind of data we need to train, right? So yeah, there are different ways. I will try to show you BERT models and see, and we'll see if we are able to clarify your doubts or not. Okay.
Sure. Thank you.
Okay. So let's pick TF-IDF and then we'll go for a short break. Um. Okay. Before TF-IDF, let me also um, clarify one more thing on BOW because I just explained you in a very layman's term. So BOW, the general context is very clear, right? Words converted into vectors, right? And then you can actually call your models. Okay. When I say models, it could be a classification model like sentiment analysis, right? Or it could be anything. And this is where little bit understanding on ML will help you, because people with zero knowledge on ML will not be able to understand what's a classification model, right? So that's why I told you, in order to become a Gen AI engineer, ML is needed, right? So let's say I have three sentences. I'll take three sentences. S1, he is a good boy. S2, she is a good girl. S3, he and she both are, or let's say he and she are good. The very first step is tokenization and then stop word removal, right? So I will just directly go and do the stop word removal. So after stop word removal, I have good boy, good girl, and um, both are good. Boy and girl. Sorry. Let's say he and she are good, or we can have boy and girl are good. Boy and girl are good. So we can remove and we can remove this. Okay. Okay. Now from this, what happens is you're basically creating your matrix, right? Bag of words matrix. How many uh, words do we have in your bag? One, two, and three, right? So boy, good, boy, girl. Sentence 1 is 110. Sentence 2 is 101. Sentence 3 is 111. Right? So the matrix of sentence 1 will be 110. Matrix of sentence 2 will be 101, and so on. So basically, when you are doing a sentiment analysis problem statement, right, what happens is you have a corpus of data, right? You have some reviews, and whether it is a positive review or not. Reviews, whether it's a negative or positive. Reviews, positive. Reviews, positive. Reviews, negative, right? Now, how do you create a sentiment analysis model here? First of all, this is textual data, right? The very first step will be tokenization, then stop word removal, right? Then let's say you are going for a BOW. So eventually what you have is, instead of textual data, you will have vectors, right? 1010111 positive, something similar negative, and so on. And now this data goes into your model. Of course, you divide 80% and 20%. 80% goes into model, 20% goes into testing. You test it out and then you finalize whether your model is performing well or not, right? But the idea is clear, right? From textual data, you are getting the numerical data, and BOW concept is clear. BOW has a lot of demerits, which I already explained. Quickly jumping into TF-IDF, and then we will take a short break. First of all, TF-IDF full form is term frequency, uh, inter-document frequency. Inter-document, right? Term frequency and in inter-document, inverse document, inverse document. Okay. Term frequency and inverse document frequency. Okay. Now, there are some mathematical formulas. TF formula is number of repetitions of word in a sentence divided by number of words in sentence. And inverse document frequency, and this is sentence specific, okay? TF is sentence specific, DF is not sentence specific. DF is IDF is overall, okay? This formula is IDF is log of number of sentences divided by number of sentences carrying that word. Okay, looks complicated, but it will be easy to understand, don't worry. So we'll take the same example. Let's say he, she, good boy, bad boy. We'll take this, okay? Okay, done. And we'll do the same step. Removal. So the first one is good boy, the second one is good girl, and the third one is boy, girl, good. Okay, I will draw boxes. One will be a TF box and one will be a IDF box. TF, IDF. So here I will write down sentence 1, sentence 2, sentence 3. Here I will write down good, boy, girl. Here I will write down good, boy, girl. So sentence 1, what will be TF of sentence 1 for good? I will do the first one, others you should do it, okay? So term frequency of sentence 1 for good is number of repetitions of word in a sentence. So how many times do we have good? One time divided by number of words in the sentence. How many words do we have? Two. So TF will be 1 by 2. Similarly, TF for sentence 1 for boy is going to be 1 by 2. TF sentence 1 for girl will be 0, right? So boy will be 1 by 2. Sorry, my bad. Sentence 1 and girl will be 0. Okay. Similarly, can you tell me TF sentence 1 for good, what will be the value? TF sentence 2 for boy, definitely 0 because boy is not there. TF sentence 2 of girl. This will also be 1 by 2. This will also be 1 by 2, right? So 1 by 2, 0, 1 by 2. So what will be for sentence 3? Good, yes, 1 by 3, 1 by 3, 1 by 3. Right? So for the term frequency, everybody is on the same page? Understood how the numbers are created? Right? Simple. Now we'll talk about IDF. I'm using this part. So IDF of good. So it's going to be log of number of sentences. How many do we have? 3. How many sentences this word is present? 1, 2, 3. So in all the sentences this word is present and it is going to be 0. So IDF of this is 0. What will be the IDF of boy? Log of 3 by 2. And this will also be log of 3 by 2. Right? So now if somebody asks you, what is the TF IDF score of good for sentence 1? 0. Right? TF of sentence 1 is 1 by 2. IDF of good is 0. So it is 1 by 2 into 0 is 0. Right? What will be the TF IDF for the same word good in sentence 2? Sentence to good is 1 by 2, multiplied with 0 is 0. So in short, for any kind of, like, good has a 0 score for any kind of sentences. That means it is not important. Now this was a drawback in bag of words. In TF-IDF, this problem is solving, right? That means in a paragraph, if you have one keyword multiple times, it's not important, right? So good is not important. Similarly, if you ask me what will be the TF-IDF for sentence 1 for boy. So sentence 1 boy is 1 by 2 log of 3 by 2, whatever the value will be, right? It's at least it's not 0, and that is TF-IDF. So we have a practicals on bag of words and TF-IDF. We'll try to go through it after this short break. I'm back. Okay, Diptarshi, Spacey and Gensim. Okay, Gensim versions of limitation have not been updated. Spacey error is that Bales support is required when I try to install Bales return for Gensim. Have you tried it on Google Colab? Try it on Google Colab. Google Colab has support on all these libraries. Right, okay. Sometimes, yeah, local Python might not, there might be issues, but try it on Google Colab, okay? Okay, quickly jumping into bag of words, okay? Now, uh, for this exercise, I'll be using um, so I'm going to use this spam data, okay, for bag of words. So spam ham, everybody is aware of spam ham. Spam means spam, ham means not spam, right? So we'll try to use bag of words to see whether we are able to detect spam ham detection in a particular sentence or not. Okay. And in this exercise, we will be using bag of words. So the very first thing that I'm going to do is I'll quickly write the codes. Okay. If you are not able to cope up with my speed, it's completely fine. The code will be given to you. You can try it out later. Okay. Assuming everybody understands Python basics, pandas and NumPy, I'll be using sklearn library for certain things like model selection, sklearn, let's say I will use feature extraction, text from sklearn.knife base. Let's say I will be using multinomial NB, and from sklearn metrics import classification report. Okay, and this is where little bit machine learning is needed. People who are completely new to machine learning might not be able to follow this, but uh, I'll try to explain in a way which is going to be understood, but I cannot guarantee whether you will be able to follow this or not. Let's see how it goes. If you have doubts, we'll try to figure this out. Okay. I'm going to import the count vectorizer, and then, yeah, all good. So NumPy, pandas, sklearn, anything else? Oh, nothing. The very first thing that I'm going to do is I'm going to read pd.read csv spam.csv. Okay. And how does my data looks like? My data looks like this, right? I have category and I have message. So these are the messages and these are categorization. How many data points do we have? we can see the data points are 5572. Now, how do we check the distribution of the classes? So just do df.category.value counts and you will be able to see the distribution. So there are 4825 good messages and 747 spam messages, right? And our goal is to identify spam, right? And this exercise is only for vectorization. I'm just showing you how the vectorization works with the context of bag of words. Okay, so what is the percentage distribution? Just do divide with the total corpus and multiply it with 100. You will see that almost 86.5% is spam, ham, and 13.4% is spam, right? So firstly, what I'm going to do is I'm going to convert this category into a new column called as spam, and in this category I'm going to apply a lambda function so that my ham is converted into 0 and spam is converted into 1. Okay, I'm using lambda function. You can also try using label encoding, that is also possible. Okay, so let's say lambda x, if x equals to spam, else 0. If I do this, dot apply lambda, uh, um, something is wrong. Df category dot apply lambda x if sorry, 1. Okay, now if you see what is my new column, you will see it's in the zeros and ones format, right? So if you just print your entire data frame, this is how it looks like. Now for me, category is not important because I have this new column which is spam. Eventually, when you're passing data to a machine learning model, right, you should always pass in numerical attributes because computers don't understand textual data. They only understand numbers. And that is one of the reasons why we need to convert this textual data into numbers. And in this exercise, I'm using bag of words. So using bag of words, I'm going to convert this into numerical attributes. So I'm going to use the vectorization part. Okay. So um, so here, let's say I'm going to make it train test split. Okay. Again, basic things just for people who are complete beginners. Quickly, I'll talk about it. So in machine learning, there are multiple problems, right? Classification problem is there, regression problem is there. Here we are dealing with classification. Okay. Now, what we are going to do is imagine we have a data set, right? And we have a category here. Let's say spam or not spam, spam, not spam, spam, not spam, and so on, right? We have 5572 records. So what we usually do is when we are calling a machine learning model, we usually divide the data into training and test. So some chunk of data is training data and some chunk of data is testing data, right? And then training data goes into the model. So the model understands the training data, and imagine this is 80% of 5572, right? Whatever it is, let's say 4000 records. So the 1572 records are going to this model for testing. That means I'm only passing this information, not this. And when I'm passing this information, the model is predicting. Predicting what? This part. Okay. So just imagine there are 5 records. Okay. 10111. Your model is predicting 10101. So fourth record, the model is not predicting properly. So what will be the accuracy? The accuracy will be 4 correct out of 5 into 100. So the accuracy is 80%. That is how we evaluate machine learning models accuracy, right? And if you are confident this model is working fine, then on a new text, let's say you pass your own text, you pass it, and then the model will be able to predict whether it is a spam or ham. Understood? In very simple terms, this is how machine learning works, right? So here I will be dividing the data. So X train, X test, Y train, Y test. And here I'm going to use train test split, and I'm going to use df of message, df dot spam. My testing size should be 0.2. Once this is done, I will show you how many training data do we have. 4457. Okay, so it's basically 4457. And how many testing data do we have? It's 1115. Okay, got it? Now, just for your understanding, I will show you few records, and these are the first few records of the training data, right? Waiting in the car, blah blah blah. Okay, now what I'm going to do is, here I will be creating my bag of words. So let's say I will write down it as create bag of words representation using count vectorizer. Okay, I will call my vectorizer v is equals to count vectorizer. X train count vectorizer is v dot fit transform, and I will pass the training data values, and testing data also I will do v dot transform test data. Okay, for training data we use fit transform because ultimately training data goes into model, right? So it has to be transformed then fit into the model. But testing data does not go into the model. Testing data is only for testing purpose. That's why we only transform the testing data. Okay, basic things. So after this, if you look at your Xtrain CV, you see it's like a sparse matrix of numpy integers, right? You cannot see this, but you can eventually see your original data, but you cannot see your CV data, right? Because these are integer format. Okay, so here what I'm going to do is, just for checking purpose, let's say I'm doing two array, and let's say one of the records I'm taking, and this is how the array looks like, right? And how many numbers are there in one array? The number of words that we have in the entire corpus, right? In the example we took, the example that we took had three words, right? Boy, good, and girl. Here, out of the 4457 records, if there are like 1 million words, imagine, right? So your vector will be having 1 million vector data, right? That is what the meaning of this one is. So here, um, mm, 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 mm. Yeah, we can also check the vocabulary. Okay, and you can see these are the different words and these are the different numbers, corresponding numbers against each word. And you can see there are so many words, right? Moving on to the next one. So here, I already have uploaded the data into the GitHub. Let me check quickly. Uh, yeah, vocabulary is there, and then Yeah. So I'm directly copy pasting it. Okay. So here I'm second. Actually, I should have directly taken the code. Um okay. Here I'm directly calling the classifier. Okay. Let's make it ML model. And which model are we going to use? We are using a multinomial NB. Okay. If you want to use something else, let's say decision tree classifier, you can use, up to you. So let's say I'm going to use a decision tree classifier. So here what you need to do is just simply call your model equals to decision tree classifier. That's it. And then model dot fit, you have to pass your X train CV and Y train. And here your model is being trained. And you can see I'm only training the training data. That's it, right? Once the model is ready, then you can directly call your model to do the prediction. And the prediction has to be done on X test CV. Okay. You are not passing Y test. Y test is not passed. What is Y test? Y test is this part, right? I'm not passing it because the model needs to predict it, right? If I pass this data also, the model will already know this is a spam, this is a ham. So there is no point in validating the model, right? So Y test is not passed. So I'm passing it. And then I'm printing the classification report. This basically shows you how the accuracy and the performance is. You can see for class 0, the precision is 98, recall is 99, F1 score is 99, which is really good. If you also want to see the accuracy score, you can also check the accuracy score. Print, accuracy score, Y test, Y pred. And you can see the accuracy score is 97%. If you want to round it up, you can round it up. Okay. 97.49% is the accuracy score. Got it? Then we can test it on a random data point. Now, this random data point is not a part of your data set. Test on a random data point. So let's say the message is something like this: up to 20% off on parking, exclusive offer just for you, right? And let's say I'm transforming this message and then I'm predicting this, and you can see the prediction is 0. It's basically telling it's not a spam, which is wrong because maybe this type of data is not available in the original data. So maybe I'll try to take some data which is similar or closer to what our spam is. Let's say free message here. Let's say I'll pick this one, not the entire one, and see whether our model is working fine or not. Hey there, darling. Yeah, you can see it's basically giving you a spam because this type of message was already a part of your corpus. So it is able to identify free Wi-Fi at 599. I'm not sure if this will work or not, but yeah, this is not working. So but eventually you understood, right? The main concept here is not the machine learning model, but how you are transforming the data into bag of words, right? So this is your bag of words technique. Maybe I'll just write it down as BOW. Okay. Similar to this, what we'll do is we'll also create another notebook for looking at the pace of the program. I don't think we will be able to complete everything in 6 hours. So potentially we will be taking a third class. And I'll let you know when to take that. Maybe tomorrow evening or something. Because we have not started transformers yet. So yeah, it's okay. I can take extra class, no problem. So let's quickly go through TF-IDF, and we will also try to understand how TF-IDF works. Okay, if you want the exact same piece of thing, you can take the exact same piece of thing and just change it here. Instead of count vectorizer, you can always change it to TF-IDF vectorizer. Okay, so let's say I have a code on count vectorizer. I need to change it to TF-IDF vectorizer. If you pass the entire code to ChatGPT, ChatGPT will be able to, kind of give you the new code with respect to TF-IDF vectorizer. You can see it's literally the same thing. It's just that you are changing the vectorizer. Instead of count vectorizer, you are using a TF-IDF vectorizer. That's it. Okay. So I will not pick the same use case. You can do this exercise by yourself. Potentially, I will try to talk about another example. Um, anything else? TF, I forgot TF-IDF vectorization should be TF-IDF vectorizer sklearn. Um, yeah, same. It's same. The name is F is small. Okay, done. Um, okay, let's say I'm taking a corpus. In fact, I will directly take it from my GitHub so that we save time instead of writing everything from scratch. So let's say this is my corpus. So Thor eating pizza, Loki is eating pizza, whatever it is. I have created a corpus. And here I'm just showing you how TF vectorizer works. Okay. I have initiated a vectorizer. I'm fitting the vectorizer with this corpus. And then I'm transforming the corpus. Okay. Now transformation is done. So if you look at the vocabulary, you see that this is how the vocabulary is. Instead of this, if you want to use a count vectorizer and just want to check, you can also do that. Just to see the differences between this and that. So let's say CV output 2, and then you pass print CV dot vocabulary. You can see that CV is equals to count vectorizer, CV fit corpus. Okay, so in this particular example, most of the things are very similar. Or am I printing the wrong thing? No, right? CV equals to count vectorizer, CV fit corpus. Let's say I'll try to change this. Apple is announcing new iPhone tomorrow. Apple is announcing new Model 3 tomorrow. Apple is announcing new Pixel 6 tomorrow. For example, I'm changing the corpus. So the output is pretty much same, right? Okay, let's try to take uh, a simple corpus. Let's say, because simple corpus, the understanding is better. Boy is good. Let's say good boy. Good girl. Boy, girl, good. No, this is wrong. Um, somehow a vectorizer. Okay, understood. This is the vocabulary. So this has nothing to do with the final output. The final output is the TF-IDF score, right? Vocabulary is fine. It's just assigning a particular number to the entire corpus words. So I was mistaken. Sorry. Okay. I'll repeat what is the meaning of this. What I'm trying to say is when your initial vocabulary is created, right? Each word is assigned to a number because in this particular corpus there could be 25 or 30 words, right? So each word is given a number. So that's why the vocabulary is same, but the final output will be different. So that's why you can see the vocabulary is same. So moving on, this is where we will be calculating the IDF score, okay? So let's say here I'm calling the vectorizer, the TF-IDF vectorizer vocabulary.get for Thor, and then what is the IDF score of Thor? And here the IDF score of Thor is 2.38. What is the IDF score of Apple? Let's say I will change it to Google. I'll change it to what else? Samsung. So Thor is 2.38. Apple is this, and then let's say Google is everything is same. Okay, let's say we will change it to Apple and Apple. Let me run it and then I will explain. Okay, it's a little bit confusing. Let's say I will have Apple, 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 Apple. So Apple is used 4 times. So in this case, inverse document frequency vector, it's an array of shape, n features. Okay, so for all the features it is showing. Okay, fine. Close this. Close this. Okay, so these are the different features. How many features do we have? It could be the number of total parameters. Okay. Okay, let's say I will try to print the IDF score now. I'll try to change the corpus name. Let's say I will make it corpus 1 so that we can easily identify corpus 1. For now, I am removing this bag of words. Unnecessarily, it will create confusion. This one, and then IDF. And let's say here I will be calling the IDF of each feature. Get features names out. We get features names out, right? Same vectorizer dot fit transform vectorizer v. Why it is throwing me error? Vectorizer has no attribute. This is weird. This feature is already available. Get feature names out. TF IDF with transform. Yeah, I'm doing the same, right? TF factorizer, corpus 1. P dot get feature names. All feature names. Why it's not working? Input features equals to none. Yeah, that's weird. Okay, let's switch to Google Colab. It's weird, right? I mean, in the documentation, it's there, but the code is not working. This one, dear factorizer, v corpus 1 transform output v dot transform corpus 1. Yes. And then let's say v dot. See, it's working. So something is wrong. Maybe it should be problem with my sklearn version. But anyways, I have switched to Colab. So same, okay. If you are facing difficulties, you switch to Colab, okay. Um, there could be a difference in the versions, but I don't have time to debug that. But anyways, I'll try to copy paste this directly here so that we see the IDF score for the entire corpus. Now you can see for Apple it is 2.38. Okay. Similarly, what I will do is just for our understanding, I will make another corpus and I will try to have Apple name more frequent, and we will see whether the TF IDF score of Apple is still the same or changing. Okay. So I have defined my second corpus. I am just making it V2 V2 corpus 2. Everything else remains the same. Transformed output 2. Sorry, corpus 2. And then I will directly take this V2 word in all featured names. Okay, let's say 2 2 index 2 V2 vocabulary dot get word IDF score 2 V2 index 2 IDF score 2. Okay, you can see this, right? Apple's TF IDF score has decreased from 2.38 to 1 point something. What about other words? Let's say already, which is 2.38. Already has not changed because I have not impacted already, right? But if you see that Google, Samsung, and Microsoft, these words are taken out, right? So potentially here there is no Google. That's why here you are not able to see any word called as Google, right? But in the first corpus, Google is there, and Google's score is 2.38, right? Please check get feature names, is it? But okay, we can try get feature names. Yeah, it's working. Yes. Okay. So maybe some local version issue. But anyways, good. This is how we need to fix problems, right? Any issues that we face, we do some research and then fix it up. Now we have Chat GPT. In our days, there was no Chat GPT, right? We were using Stack Overflow. So understood, right? This is how you I will write it down as TF-IDF collab. Okay. Now, as an exercise, what you can do today is the exact use case that I used in Bag of Words. Try to take the exact use case and try to create TF-IDF vectorizer and see whether the model's performance is increasing or decreasing. Okay, as an exercise, you can do this. So we will quickly jump into the next topic. We'll see how much can we cover today. If not, we will be covering next class. Bag of words is done. TF-IDF is done. Word2Vec. Okay, let's try to cover Word2Vec and then potentially next topics like transformers, BERT models, we will try to cover tomorrow. Okay. So moving back to my Miro board. Bag of words and TF-IDF is understood. So we will talk about the next one, which is Word2Vec. So Word2Vec is a prediction based word embedding model, and it is a very famous model. It's a very good word embedding model. Okay. So when somebody asks you in interviews, you can potentially talk about primitive techniques like bag of words and TF-IDF, and recently what to vector you can also explain, because this is a latest technique, like very new technique 5-6 years back, and then it's a very good technique. Okay, it's a prediction based word embedding technique. Now there are two different versions of it. One version is a pre-trained model. So Google basically has created a word to vector model. I will write it down as Google has a word to vector model of 30 billion data. Okay, and with 300 features. You can leverage this and try to use this and convert your data into 300 features, or else you can create your own model. Okay, some of you might be confused here. What do we mean by pre-trained and own model, right? So pre-trained model means, so Google already has created a word to vector model. Okay, and Google has used 30 billion data points or 30 billion words. Using that, they have already created a word to vector model of 300 features. Okay, so in short, it's a huge corpus of data. And how many features do we have? There are 300 features. And this is a pre-trained model. Pre-trained model is something which is already trained by a big organization. And if you want to leverage that model, you can use that model. Now, if you have a specific problem statement, okay, I'm taking the same example, sentiment analysis. You have reviews, you have positive, negative, and so on, right? Initially, we were using bag of words. Now, let's say to convert textual data to numerical data, we will use word to vector. Now, in this, there are two techniques. Either I use this or I create my own model. Obviously, if you use this, the accuracy will be higher, performance will be better, because they have already created a existing model, right? So if you go through this Google's word to vector model, what will happen is all of these sentences will be converted into vectors of 300 features. That means sentence 1 will have 300, sentence 2 will have 300, sentence 3 will have 300, and so on. And once this numerical data is ready, you convert this into ones and zeros, and you apply the same technique. Divide the data, training data, testing data. Training data goes into model, testing data goes for testing, and you check the accuracy. If anybody has any concerns here? If not, I'll proceed. I'll try to explain what is exactly the intuition behind this. So we'll potentially go through the code. Let's say I'll quickly open today's class. We'll try to shift it little bit so that we can at least finish word to vector, and tomorrow we will see the rest of the topics. Okay. Um, so let's say I will write it down as word to vec pre-trained. Okay. So I'm using Gensim. From gensim.models import word to vec and keyed vectors. Okay. Yeah, it's running fine. In case, in your case, if it is not running, switch to collab. Okay. Then I already have data in my the Google News vector data is already in my Google Drive because I had used it. Google Google News, Google News, this one. So this is the pre-trained model by Google's. Okay. So I'm just checking the path. How to check the path? It's okay. I can directly pass the link. So let's say from google.collab import drive, and then drive.mount content slash, it will not work on the local system, right? Or it works? No, it will not work. So I will try to download this. How big is this model? Not sure. 1.5 GB. Okay, let's not waste time. I'll directly switch to Google Colab. Okay. Um, New notebook. So whatever has been taught today or is going to be taught, please spend some time today, do some practice, and come back with questions. Okay, because if you don't come back with question, that means you are not serious. As simple as that. Drive, uh, drive.mount content drive. So here what happens is the Google Drive will be mounted. It asks for your details, and then you have to give permissions. Permission is granted. So you will be able to see your drive here. Now it's not visible because it's still loading, but you will be able to see. Okay, able to refresh, able to see. So here basically I have to go to my drive, and inside my drives there is this Google News folder. I'll have to search where this is. Google, this one. Okay, and this file, just right click, copy path, and here you can easily call model equals to keyed vectors dot load word to vec format, and then here you have to pass this um, word to vec pre-trained models. Oh, binary is also needed. My bad. Binary true. Okay, I have this model. Now in this model, I will try to randomly call some of the words, and we will try to see what are the uh, feature values. Okay, because as I told you, this data is already trained on billions and billions of data, right? If you pass any word, let's say uh, let's say I'll pass human. You can see I'm able to get the array representation, right? And if you check how many numbers are there, if you start counting it, 1, 2, 3, 4, 5, 6, there will be 300. Okay, just to check, you can always go and check the shape of it, right? Let's say model uh, human shape. Sorry, my bad. Human dot shape. You will see 300 features because I told you, right? We are using Google's what to vector model, which is already created on 300 features. Okay, so this is how it is. Similarly, you can also check for, let's say, man, woman, king, blah blah blah. Okay, so multiple words you can do. Similarly, inside this model, you can also find some similar words. Let's say I want to find the most similar word for a man. The most similar word for a man is woman, boy, teenager, teenager girl. These are most similar. Similarly, let's say I want to find most similar word with keyboard. You can see keyboards, keyboard, touchpad, trackpad, keypad, QWERTY keyboard, stylus, right? These are the most similar ones. Similarly, most similar with cricket. Definitely there should be sports, but no, there is no sports. Could be there, but the score would be little bit less. Cricketing, cricketers, all these things are there, right? Apart from that, you can also find the similarity score. Let's say you want to find the similarity score between, let's say, man and woman. What is the similarity score? The similarity score is 0.766. What is the similarity score of man and, let's say, Python? It is very low, right? Similarity score with man and something else. You can just give it a try. Use this notebook and just try it out. There is also another method inside this which is called as doesn't match. Doesn't match. Let's say here you are passing a list of attributes. Let's say Java, uh, JavaScript, Python, elephant. Oh, JavaScript. Okay, this is not correct, but anyways, Java, Python, elephant, Java. Okay, this is not correct. Maybe no. So yeah, it has flaws. Okay. Um, Another thing that I would like to show is, let's say I will create a variable. Let's say x is model score of king. Um, this is a very classic example of showing how what to vector model works. Let's say king minus man plus woman. What is x? X is, okay. Instead of x, I should write model dot most similar with x. And model with most similar with x is king. So king minus man plus woman, the most similar is king. Then we have queen. So basically this means king minus man plus woman is basically queen. This is what the interpretation is, right? So this way you can actually leverage the existing word to vector model, pre-trained models, and using this you can converge your data into vector representation and then follow the same steps. Just copy paste the bag of words notebook. You just have to change the vectorization step. That's it, right? And then call the model and see. And eventually, for one particular use case, you will be able to understand whether bag of words is performing good, TF-IDF is performing good, or word to vector is performing good. Okay. Last topic before closing is how do we create our own word to vector model? And this is the last topic. and then we will close it. Okay, already 3 hours has been crossed, and I cannot speak more, so I need a break. Let's say I want to create my own model, and I will take an example. See, the goal is very simple, right? The goal is to find the semantics between words. That is the goal. Now, let's say I have a vocabulary of 5 words. Okay, vocabulary of 5 words. Now, for a vocabulary of 5 words, I need to define how many features I want to create, right? Let's say in this example, I am creating 5 features. It could be 10, it could be 20 also. It depends on you, right? So I'm just taking a sweet example, 5 features and 5 words. Okay. So what are my 5 words? King, queen, man, woman, elephant. And this is a very classic example. Um, the feature one is, I will write it down as F1, F2, F3, F4, and F5. Because features are not known, right? Just for simplicity, let's say F1 is gender, F2 is, let's say, money, F3 is, let's say, power, F4 is, let's say, weight, and F5 is, let's say, speak. Okay. Now, as we are creating our own word to vector model, I need to give numbers, right? A number should be in the scale of 0 to 1. Gender, king is male, queen is female, man is male, woman is female, and let's say elephant is male elephant. Dollars, how wealthy a king is? Very wealthy. King and queen both are wealthy, right? Let's say man is somebody like us, broken, uh, still wealthy, but not having as much wealth as a king, right? So let's say 0.3. Woman also, gender equality. So I'll give 3. If I give zero point 0.2, you might complain why woman is given less. So zero point 0.3. Elephant has no money, 0. Power, the king has a lot of power, right? Queen also has powers, but more power is with king, right? So power wise, let's say I'm writing it as 0.7. Let's say man has a power of zero point 0.2, and let's say woman also has a power of zero point 0.2. Elephant also has good amount of power, like physical power, so zero point 0.5. Okay, or if you want, you can make it 1, up to you. Weight, let's say king is zero point 0.8, queen is little bit on a lighter scale, zero point 0.4, man is, let's say, zero point 0.6 or zero point 0.8, whatever you want to give, and woman is, let's say, 0.3, 0.4, 0.5, whatever you want to give. And elephant's weight is little bit high, so zero point 0.9. Speak, yes, 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 unless somebody is dumb, right? um, Now, what is the vector representation of king? It is 111.81, right? So if I write it down, the vector representation of king is 111.81. What is the vector representation of man? 1.3.2.61. What is the vector representation of woman? 0.3, 0.2, 0.5, and 1. Now, going back to the this example, right? King minus man plus woman. In this, we were able to get, yes, that the most similar attribute to king minus man plus woman is almost queen, right? Almost 73% match. So we will do the same activity minus man plus woman. So what is the score? King minus man, 1 minus 1, 0 plus 0 is 0, right? 1 minus zero point 0.3 plus zero point 0.3 is 1. 1 minus zero point 0.2 plus zero point 0.2 is 1. Zero point 0.8 minus zero point 0.6 is zero point 0.2. 0.5 is zero point 0.7. 1 minus 1 is 0 plus 1 is 1. Now, what is actually the queen's numbers? 0 match, 1 match, zero point 0.7 almost, 0.4 almost, and 1 is match. So almost 70-80% match is almost there, right? So what to vector models? You can use a pre-trained model. You can create your own model as well. Okay. So that is it. Let's say I'll try to proceed in the code. So here, what I need to show you is I need to show you a heat map. Um, so let's say I'll try to copy paste the code directly from my workshop folder. So everything is shown to you. So this code basically shows you the, you know, initial 50 features out of the 300 features, the 50 features. Okay. And this piece of code basically shows you, um, let's say you want to have only the 10 features, and based on 10 features I'm taking these words and I'm creating the data frame, and I'm going to create a hash map. And you can see this is the, not a hash map, it's a heat map, right? It's a heat map. So you can see this is the heat map. So on your y-axis, you see the different words. On your x-axis are different features, right? So it's feature 1, feature 2, feature 3, blah, 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 feature 10, right? So feature 1, you can see man has a higher number. Woman also has a higher number. King has low numbers. So I don't know. It could be like, the feature could be like whether he or she is a normal person or not. I don't know. The feature names are not known. That's why they are treated as 0, 1, 2, 3, 4, right? But if you want to visualize your features, you can also visualize like this. So that is it. In the next videos, we will be getting into transformers. So tomorrow, first 1 hour, we will talk about transformers and GPT architectures, which is most important for generative AI. Second hour, we will try to get into the RAG pipelines, and then the third hour will be the project. If we are not able to complete, we will try to extend the class. That's it. I'll keep the call open for next 5 minutes. In case you have any questions, you can ask me. In the meanwhile, I'm just downloading this and trying to push it to the GitHub, just in case. But the call is open. You can ask me doubts if you want to.
So what is BERT?
BERT will be covered tomorrow. BERT is a encoder architecture. So after NLP, we have transformers. Okay. And all this generative AI is nothing but transformers. So in transformers, there are two parts, encoder and decoder. Encoder takes the input, encodes, sends it to the decoder, and decoder is the one who is generating the final output. So BERT is nothing but an encoder only architecture. So there is no decoder there. So BERT is good for certain NLP tasks, but you cannot solve everything with BERT. BERT has its own limitations. Similarly, GPT, which is nothing but generative AI, the GPT architectures, those are decoder only architectures. So tomorrow, first half, we will be covering these transformers and encoder only and decoder only, and then we will jump into other topics. Google News data, I will not be able to upload because it's a 1.5 GB this thing, right? But what I can do is I will share this in case you want to download, you can download. So I will mention it in the README. Okay. Thank you all. I think it was a productive session. For some of you, it was little bit way too technical, right? But this is how it is, right? Workshop is little bit fast paced, but it has its pros and cons, but more pros than cons. Recordings will be available. I'll just have my lunch and quickly upload the recordings. I'll in fact create a new course on zepanalytics.com. It will be an internal course, not publicly available. I will send you the course link in the WhatsApp group. You can directly join. It's free of cost. Directly join it, okay? And in that course, you will be able to see the videos, okay? And code, anyways, I already have it. I'll send it in the chat box. Okay. Thank you all. See you tomorrow. Bye bye. Thank you. Thank you. Tomorrow we'll also have a poll on how your understanding on Gen AI was before this workshop and after this workshop. Okay. See you. Thanks. So we will get started with the introduction to transformers. In the previous classes, like in the yesterday's class, we learned about introduction to NLP, pretty much about the basics of NLP, tokenization, stop word removals, many more things, which eventually will help you, not directly, but somehow indirectly, because these are all core concepts, right? Without which uh, getting into generative AI is kind of not recommended. So let's go ahead and try to understand transformers. Okay. Now, before explaining you anything about transformers, I would like to uh, kind of generate something. Let's say write a 10 line paragraph about MS Dhoni. Everybody understands who MS Dhoni is. Now, this is the text I have, okay? Now, try to, okay, I'll give you 2 minutes. Can you try to translate it to your local language, maybe Hindi or whatever language you know? Try to translate it in your head. Don't write it down in the chat box. Try to translate, and after 2 minutes, tell me what is the difficulty that you are facing. Just 1 more minute. Okay, can somebody write it down? What is the difficulty, or is it, first of all, is it easy for you to translate? If I give you 30 minutes, you will probably able to translate, right? But immediately it's difficult. Now, what is the problem that we are facing while translating such a huge message? Can Okay, is it's easy to translate for you? I mean everything. So, okay. Now, can you write down the translation? I have removed the text. Now you cannot, right? So see, try to understand. I mean, try to technically understand what is the problem. Technical problem is when you are trying to translate to Hindi or any local language or whatever language you prefer. The problem is our brain is not able to process everything in one go. So if I ask you, okay, try to read about this, and then I delete it and then give me the translation, you will not be able to do, because your brain is processing it line by line, right? Because it's a huge text. And if I give you one line, potentially you will be able to do it very easily. Next line, you will be able to do it easily because our brain is good enough to process sentence by sentence, right? So when you work on NLP problems like this, when you have huge amount of data, sometimes it is difficult for our human brain, right? Similarly, background of NLP is the way we deal with NLP use cases is using neural networks. Okay, that is where deep learning comes into picture, right? So neural networks is, it's difficult to work with neural networks if your model is not good enough, right? So basically, few years back, some researchers identified these challenges with respect to natural language processing, how to make machines understand and generate human languages more efficiently or effectively. So traditional models basically struggled with long sentences and complex structures. Okay, and based on which the performance went down. So there were tasks like translation, text generation, and so on. And that is where transformers were created. Transformers were literally created in like 6, 7 years back. I would say 7 years back in 2017. And who created this concept of transformers? Google. It was Google Brain who created transformers. Okay. Now, in layman's term, let's try to understand what transformers are, and then in non-layman's term, little bit technically, I will try to explain you. So, in layman's term, how does a transformer look like? So, first of all, what problems does a transformer solve? It solves machine translation. It solves Q&A systems. It solves chatbot problems, text summarization, sentiment analysis. So, in short, each and every problem in the space of natural language, when we are dealing with text, is being solved by transformers. Before transformers came, we were still solving NLP problems, no doubt about it, right? The techniques that I have explained to you in the last class, all the techniques, we have to manually do it one by one by one, and then manually call the model. So in before transformers came into picture, let's say we wanted to solve a sentiment analysis problem. So we have all the sentiments, reviews, and we have positive, negative, so on. We were kind of, first we were doing the stop word removal, then we were doing the case folding, like converting it into smaller case, then removing all the, irrelevant characters. Okay, I would write it down as data cleaning. And then you were doing word embeddings. Let's say you are doing word embeddings using uh, bag of words or TF-IDF or what to vector, these kind of things. And once your data is vectorized, you're basically calling the machine learning model for classification. This was a traditional approach, right? Now, using BERT, okay, we'll talk about BERT later, but using transformers, things can be done in a better way. More data can be used, and better understanding of data will be done by the transformers. Now, how transformers is able to do such kind of activity. What was the idea behind transformers? So first of all, transformers came in 2017. Okay, who brought this idea? Google Brain. Okay, literally whatever we are using right now, generative AI, all these chat GPT, everything comes from this particular source called as transformers. Okay, so many researchers have actually told that, you know, the people who wrote the concept of transformers are like extremely talented. It was like somebody time traveled back in 2017, gave them that, okay, after 5 years, 10 years, something like this is needed by the world, generative AI is needed by the world, and somehow they wrote the paper. It was treated like that. So transformers is a revolutionary thing in the space of data science and AI. Okay, now what is transformers? Transformers is simply nothing but a combination of encoder and decoder. Okay, simple English keywords, right? You know, encoder is encoding. Like you have, let's say you have your passport number or bank account number, you are encoding it, and then eventually you are decoding it, right? Simple. Okay, so in simple terms, what is an encoder? In simple terms, encoder is nothing but a listener. Okay, that means they are skilled listeners. Like you, I'm speaking right now, and you all are consuming, you all are listening. Right now, you all are encoders. So they basically take sentences. So whatever input that we provide, that input is nothing but sentences, right? They are taken internally in encoder, they are broken down, and then you understand the meaning of the sentence, contextual meaning. Let's say, I saw a python on the road. Python is a programming language. These two sentences are different, but contextual meaning. In the first sentence, Python is potentially a snake. Second sentence, Python is a programming language, right? Traditionally, if you add these two sentences, Python will have, Python is Python, right? If you use bag of words, so let's say sentence one, I, okay, I saw, let's say there was a python on the road. S2 is, Python is a, let's say, language or programming language. Okay. Now, in this case, if you do all the stop word removal and all those things, imagine you have Python and road, and then Python programming language. Right. Now, if you use bag of words, what will happen? We have Python, we have road, we have programming, we have language. Right? We have sentence one, we have sentence two. Sentence one, is there a Python? Yes. Is there a road? Yes. Is there a programming? No. Is there a language? No. Sentence two, is there a Python? Yes. Is there a road? No. Is there a programming? Yes. Is there a language? Yes. Now, what is the sentence one interpretation? Vector embedding is 1100. Sentence two, 1011. Right? Contextual meaning is not understood, right? So this is where transformers come into picture, because when you feed the data into encoders who are listeners, they basically understand the contextual meaning. Imagine the sentence is, the cat sat on the mat. Classic example. Who is most important here? The object, which is cat, sorry, the subject, which is cat, and the object on which it is sitting, which is mat, right? So the most important keywords are cat and mat. So encoder is able to understand that pattern. And how does it understand? Of course, technically also I will explain you, not quite in depth, because this transformer topic itself takes a lot of time to teach, but I will try to explain in um, as simple and as fast as possible. Okay. And after the workshop, in case you still have any understanding difficulties on any topic, you can let me know, and we'll figure this out. Now, encoder passes all the information, all the context that it has consumed with contextual meaning to decoder. Decoder are storytellers. So it's something like, now in the class we have Sumit, we have Ravi Kumar, we have Karthik. Right now, whatever I am telling you, I am giving you the input. Okay? You are the encoder. Imagine you have a friend to whom you have to explain. Will you be able to explain exact word by word to him whatever I'm explaining in the class? No, right? You will kind of summarize it, right? Yes. So you are playing the role of a decoder. Able to understand? Very simple explanation. If you go to YouTube, you go to various other platforms, transformers are explained in a very complex way. The simplest explanation is this: I am providing input, you are listeners. Without asking anything, you are just consuming my knowledge. Word by word, you are consuming. You are storing it in your brain. Tomorrow, if your friend asks you, can you explain me about transformers? You will not be able to take 1 hour, but eventually you will take around 15-20 minutes. Word by word, you will not be repeating me, right? You will be summarizing and explaining. So you are working as a decoder, right? So if somebody asks you, encoder is a listener, decoder is a storyteller. They take the understanding from the encoder, generates a new sentence, and then gives you the output. Okay. So that is the work of an encoder and decoder. Now, this particular concept was tossed in 2017, right? We call it as a sequence model. Input is a sequence, output is a sequence, right? Input is what I'm teaching you in a sequence. Output is also in a sequence, but in a different wordings. It's kind of a summarization, right? So after 2017, I mean, in fact, after transformers were created, there were certain difficulties in certain areas. Well, transformers were better than the previous models, but we all are part of evolution, right? We all have evoluted from our previous instances, from apes to human beings, right? And eventually we are also evolving, we are learning new things. So people who were born like 50 years back versus you, we are better versions, right? We are evolving. Similarly, transformers also had some flaws. I would not say flaws, but researchers started understanding that why do we have a complex encoder decoder architecture? Let's try to divide it. Okay, so let me first draw encoder and decoder architecture so that we understand theoretically and also uh, um, kind of also understand the architecture. Okay, so let me draw and then I will explain. So basically, yeah, to to sequence model came. Okay, the paper was released in 2017, but I think sequence to sequence came in 2014 or 15. Sequence to sequence networks paper, Ilya. Yeah, it came in 2014. And what about transformers? Transformers. So it was neural machine translation by jointly aligning. When was Transformers created? Not this one. Transformers NLP created. Okay, some people said 2016, some said 2017. It's okay, doesn't matter. Years does not matter. So yeah, just if somebody asks, you can say 2015, 2016. Okay. So the first paper was released on sequence to sequence models, which was then not termed as transformers, but the name transformers was given around 2016, 2017. Okay. So this architecture was explained in this sequence to sequence paper, which was released in 2014. Okay. Now, what happens is, so this is how your input passes. These are your embeddings. Okay. And then your input basically passes to these blocks. This is your encoder block. This is your decoder block. And decoder also passes it step by step. And then your final output goes through activation layer. Many of you might not know what an activation layer is. It's something related to deep learning, but again, I cannot go in depth into this. So just high level understanding. There is an encoder, there is a decoder. Here also um, we have embeddings, and here also we have inputs. Okay, so basically here also there is some input, and then it passes on to the decoder. Decoder also has an input, and then it also combines this with this and gives you the final output. So something like this was explained in the 2014 paper. Okay, so you can call it as an encoder and decoder, but this is not how a traditional in 2017 the architecture was changed. Okay, like this is not the actual architecture of a transformers. That's why I told you in 2014 it was not called as transformers, it was rather a sequence to sequence model. Okay, now this particular model was introduced, and also it has some flaws. The flaws were on larger data. This type of model or architecture was not working properly. The accuracy was very low. And that is when in 2016, 2017, there was another revolutionary thing where transformers were introduced. Okay. And how does a transformer look like? Uh, it is something like this. Let me take an example of a translational project. Let's say we are trying to translate uh, turn off the lights. And what will be the translation of this? Let's say if I do it in Hindi, um, light band karo, right? Right? So this is the translation in Hindi. Those who don't understand Hindi, it's completely fine. I'm just translating English to Hindi. That's it. Okay. So the architecture looks like this. Let's say we have something here. We have something here. The input is basically coming from here. We have an embedding layer. So these are your inputs, turn of the lights. And here you have different transformer blocks. Message is being transferred. So when the first word comes to the model, when the word comes, the model only has turn. Then the model has turn off. Then the model has turn off the. Then the model has turn off the lights. As simple as that. Okay. This is how the data is passed. From here, okay. And then this is your decoder architecture. And let's say your output of decoder is something like this, right? Light, बंद करो. So we have an encoder, we have a decoder. From encoder, data is going in, getting injected. There are different layers in decoders. Okay, there is self-attention layers and various other things. I'll try to explain what is attention in short. But this is how the data flow happens. Okay, now what exactly is this? This is basically translation of this part, right? Turn off. Okay. Now, if I talk about different layers in simple terms, to predict this, do we need the entire sentence? Yes or no? To predict this, do we need the entire sentence? No, right? This is called as attention. That means to predict light, you just need this instead of all four, right? So the model understands that this is the attention. The model needs to have attention here. So for light, basically you need, let's say I will write it as x1, x2, x3 and x4. So to predict light, you basically need x4. Rest others are irrelevant. To predict this, you basically need x1 and x2. So this is basically the attention mechanism based on which transformers are created. Okay. So you don't need the full sentence, right? You just need the partial sentence of it. Now, mathematically speaking, the formula is, so let's say for light, right? So for light, let's say I will write it as, let's say C1 and write it as C2. So basically the formula is, mathematically the formula is um, Lij Hi. So Hi is basically this part. So let's say for C1, you are taking um, L1, L2, so L1 H1 plus L2 H2. Basically these two parts. So there is a, this is where, deep learning comes into picture. It will be difficult for us to understand this. If you don't understand deep learning, it will be difficult. So let's not get into this, okay? Just understand the basic flows so that you will be able to answer at least what is attention, what is transformers, and so on, right? Now, so this was transformers. Now evolution again. As we are part of evolution, there were other things as well. So some researchers started analyzing this architecture separately. Some tried to analyze this, some tried to analyze this separately, and that is where we had two different versions of it. One of them is called as a encoder only architecture. Okay, and there was decoder only architecture. Okay, because encoder has a different task and decoder has a different task. So researchers started analyzing this entire transformer architecture into two different components. Okay, and this basically led to a development of encoder only and decoder only architecture. Now, what are encoder only architectures? Encoder only architectures are models which focus solely on understanding the input. Okay, so of course, you don't have the decoder part, only the encoder part, right? So input is very important for encoder only architectures. So they were focused to understand the input better. And encoder only architecture showed some revolutionary results in specific tasks like text classification, sentiment analysis, these kind of problems. So for example, if you want to determine whether a movie review is positive or negative, right? An encoder only architecture can analyze the review and provide a clear answer. Okay. So what is a decoder only architecture? In decoder only architecture, you basically don't have the encoder part. To the decoder, what goes into input is the output of encoder. Okay, this is how the architecture of encoder decoder looks like. Now in decoder, this part is not there. So eventually this part is not there. So output is there, which is fine, which is understood that decoder only architectures are good at generation of text. Similarly, encoder only architectures are good at understanding the input. Okay, but fine, good at generation of text, but what will be the input here, right? There is no input. So, one second. Just give me 1 second. Yeah, sorry, I just got a call. Okay, so understood. Encoder only architectures are good at understanding the input. So they are good for tasks like text classification, sentiment analysis, and so on. Decoder only architectures are good at generation of text. But my question here is like when I first studied about decoder only architecture, well, the first question comes to my mind is if this is not there and this is not there, what will be the input to this model? There is no input, right? There is only output. But what will be the input? So there will be a input here, which is basically called as prompt. And this is where the new stream of learning started, which is prompt engineering. How to write better prompts. Okay. So in simple terms, decoder only architectures are designed for generating text. And they are particularly useful in applications like chatbots. So I will try to copy this part and try to write down uh, use cases. So the use cases are chatbots, um, generation of text. So creating articles, generating scripts, these kind of things. Okay, these are the use cases of generative, like not generative, but decoder only architectures. Okay, so now one question might also come to your mind that okay, this is good at something, this is good at something. We already had a combinational model which solves everything, right? Why do we have to divide these architectures? Does that come to your mind? If yes, the answer is very simple, right? Imagine person A who knows a particular skill X, X1, and a person B who knows a skill X2, and a person C who knows both the skills, but he's not a pro in both of them, right? So usually we will, like, from a for a layman's point of view, yeah, people will think, yeah, we should go to this person, right? Because he knows both. And there could be a situation where both is needed. But now I will tell you that there is no situation where both is needed. Now, to whom will you go? For X1, you will go to A, for X2, you will go to B, right? And that is what it is. Encoder only architectures are perfectly designed for understanding the input and analyzing the input. And decoder only architectures are designed specifically for generation of text. Okay, that's why if you want to pick these kind of tasks, you can go here, else you go there. Now, what are the different type of architectures under encoder only? And what are the different architectures under decoder only? Under encoder only, this is where BERT is there. Somebody was asking about BERT yesterday, right? BERT, BERT. And different flavors of BERT are also there. We have Alberta, we have Roberta, we have Distill BERT, okay, and and there are some mini versions of it, mini Albert, mini Roberta, mini Distill BERT, many are there, and they are all different versions of BERT. So if you understand BERT, more than good enough, because all other things are just manipulations of BERT model. Okay, it's something like people have introduced cricket, and these are different versions of cricket: 50-50, 20-20, tests, T10, blah blah blah, right? So if you understand what cricket is, good enough, right? And later on, literally you can study about these three, about their differences. Even on ChatGPT, 1 minute of read, you will be able to understand the differences. Now, what exactly is BOT? First of all, let's try to understand. Okay, what is a decoder only architecture? Decoder only architecture is GPT. This is where the generative AI comes into picture, right? Generative pre-trained models. Okay, so let's first try to talk about BERT. Just tell me yes or no. Do you anybody here who knows BERT? Just yes or no. Okay, everybody is a no. Okay, uh, note it down. BERT is nothing but, let's try to write down the full form first. And from the full form, you will be able to understand a lot of things. Bidirectional encoder representation of transformers. So I will write down T in capital to give respect to transformers. This is BERT. Now, can somebody just a quick guess from the full form, right? What does it mean? I mean, any idea? Now focus on this part, okay? Bidirectional. Bidirectional basically means when you are interpreting a paragraph or a sentence, usually from a human being point of view, what we do is we process the text from right to left. Sometimes we also process from from left to right. Sometimes we also process from right to left. Okay, and when we process text from right to left, it's not literally like cricket Indian of history, not like that. But imagine you are reading the first sentence. Okay, MS Dhoni referred as MS Dhoni is one of the most celebrated cricketers. Sometimes we also read it from back, right? History of Indian cricketers, MS Dhoni. Okay, I mean, not word by word, but just getting a gist, right? But in Encoder only architecture, especially the BERT model, the direction is both ways. It is forward and backward, which helps in understanding the context even better. So that is the advantage of this particular model, encoder only model, and that's why it was created as a specialization in the field of encoder only transformers. Now, BERT is very famous for solving problems like sentiment analysis, next word prediction, and text classification. Okay, so I'll write it down. Some of the use cases of BERT are sentiment analysis, next word prediction, next word. Of course, next sentence prediction also can be done. Um, but let's not try it because it's not quite good at that. Next word prediction, yes, it does flawlessly. Next sentence prediction will be something like it will be the exact sentence that was a part of your input data, right? It will not generate something out of the box. So next sentence prediction is more suitable to decoder only architecture. Understood? So I will not write it down because it's not good at that. It can still be done using BERT text classification. Okay. Now, how does the architecture of BERT looks like? Let me try to draw it here. So let's say we have X, which is your input, and then we have the embeddings. And after the embeddings, there are some encoding techniques. So I will write it down as positional encoders. And here comes the main masala, which is we have block 1, block 2, block 3, dot, 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 dot. Let's say block 12. So let's say transformer block 1, transformer block 2, transformer block 3, let's say transformer block n. And then final is nothing but your prediction head. Okay. Now I have written down 1 to n this thing. Imagine here instead of n we have 12 blocks. That makes it a BERT base model. Okay. So BERT base uncased model, uncased model architecture comprises of 12 transformer block layers with each having a hidden size of 768. So imagine this block is nothing but a neural networks. We have input, we have hidden layers, and then we have output. So each block is something like this, a hidden layer. I mean, a neural network. Okay. So now imagine what is my X. Let's say my X is uh, Ali is walking. Ali came from the garden. Okay. Now these are my sentences that goes into the X. Okay. And this word is basically masked. Masked means it is hidden. Okay. So just imagine for the model, it looks like this, right? There is nothing here. Ali is walking. Ali came from the dash. And then embeddings are created. whatever it is, 110011, whatever the embeddings are created, goes through the encoders, goes through these transformer blocks, and then comes the prediction head. So what does the prediction head does? The prediction head basically predicts words. Okay, let's say it predicts garden, it predicts city, let's say cool, hotel, and the probability scores are, let's say, zero point 0.6, zero point 0.1, zero point 0.05, uh, zero point 0.25. Or if you have more predictions, you can add it, but this is just an example. And as garden has the highest score, you are able to get the final answer as garden. Okay, understood? Simple. So this is exactly how a encoder only architecture works. Hmm. Now we will be a little bit fast. So in case you have doubts, you can still ask me. There is nothing to worry about. Or else if you want time to grasp, watch this video once more once the videos are released. And if you have doubts, come back to the group and you can ask me. Even in generative AI workshop group or any other groups you are part of, you can ask anywhere. I mean, I respond to questions, right? So next one is decoder only architectures. And example is a GPT architecture. Okay. So we have the encoder from which it goes to the decoder, and decoder gives you the output. So we don't have this and we don't have this. So how does the input gets passed? There is a new which is called as a prompt. Okay. Um, there are few technical things here. If you want to read through, you can read through. I will skip directly to the GPT architecture. So positional encoding is something like, I'll give you an example. So here you can see in this presentation, I'll potentially remove some of the very technical things which is not needed as of now. But if you want to deep dive, of course it is needed. Um, so you can see in this PPT, I will be releasing this also. So after BERT models, there are some different versions of BERT models, which is Robota, Distilbert, and so on. You can potentially Albert is also there, which is a light BERT. Um, you can potentially use ChatGPT to kind of generate the differences between each of them to understand. Okay, what exactly is this model? So basically, if you see in the BERT model, there are 12 blocks, right? And each block is different from each other. Now, if each block is identical, that becomes a Albert model. As simple as that. That is the only difference between BERT and Albert. Okay. And which one will be better? Nobody can say. In the world of machine learning and deep learning, we usually go for a hit and trial approach. Okay. If you are trying to solve a um, text summarization or a sentiment analysis problem statement, then you should always try out different models, BERT models, then Albert, Robota, and then see which one is giving you best results, right? Because depending on the data set that you have, depending on the problem statement, different models will behave differently, right? If there was a rule book that Robert I is the best, Albert is not the best, then everybody would have blindly gone through Robert, right? It's not like that. So there are different BERT models we have to hit and trial. Similarly, in the space of GPT also, we have different models. We have GPT-4, GPT-4o Mini, GPT 3.5, Llama, Mistral, Mixtral, many are there, right? We really don't know which model will work the best in your data. So it is always a hit and trial process. Okay. So positional encoding, I will explain you. Decoder only architectures we will jump, which I did not explain you decoder only architecture in depth because that's the agenda right now. We will be learning more about large language models and various other things, which are nothing but decoder only architectures. So so let's go for a short break. We'll be back and then we'll jump into the decoder only architecture. Okay, we'll proceed. So before proceeding to decoder only architecture, there was a question, right? So positional encoding. Okay, let me try to take the same example so that maybe I'll try to explain here itself, somewhere here on the right hand side. So basically, see, positional encoding in just one line is nothing but it 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 basically understands the position, right? It stores the position. Okay. So what is going into this transformer block is nothing but a addition operation from embeddings and this positional encodings, right? So so let's say if I have to do the embedding, okay? Now input sentence is Ali is walking, Ali came from the garden, right? And garden is the masked word, right? Um, so when we are creating the embeddings, right? So each word, let's say each word is a token. Okay. Ali is walking, Ali came from the garden. Each word is a token, right? So each word is converted into a vector representation, right? So let's say Ali is vector A, is vector B, walking is vector C. Let's say again Ali is vector A, came is vector D, from is vector E, the is vector F, and so on, right? Um, and this one basically is, let's say, vector M, right? If you want to remove the stop words, you can remove it, up to you. I'm just giving you a very layman's understanding on positional encoding. Now, talking about the positions, so basically Ali is in first position, right? And then is in second position. Then walking is in third position. In fourth position, there is a dot. In fifth position, again there is Ali, right? In sixth position, there is this. Seventh position, there is this. Eighth position, there is this. Ninth position, and then 10th position, there is this, right? Now, this embedding, this is your vector embedding, right? Or your word embedding, right? And this is your positional embedding. Now, when you combine this with this, is what you get is the word embedding plus the positional embedding. And that goes into the transformer block. Now it is understood? Simple. Okay. So if you have such kind of problems, right? I mean, in the future, for example, um, you have any kind of doubts, right? um, Try to formulate the doubt in a way which is understood by ChatGPT, and you can actually rely on ChatGPT without relying on somebody to answer you. Let's say, for example, in the future, um, I'll give you an example on how to write a good prompt, right? Because this is very important. Now we have ChatGPT, which can actually help you in your journey. It's not 100% accurate, but at least it helps you, right? If somebody else who is more knowledgeable is there with you in your journey, of course you can ask them. So let's say you can ask me, but if you don't have to rely, you can simply use ChatGPT, right? I'll help you in how to write a proper prompt. Now, for example, I'll take the same example. Okay, so let's say Ali is walking. Ali came from the garden. I have a sentence. Ali is walking. Ali came from the garden. Here, garden is masked as per my trainer. I understand that when we pass the input to embeddings, then there is a positional embedding um, before we feed data to transformers block. Transformers block. What exactly is the positional embedding doing? Explain me in layman's term using the same example I wrote. Something like this, if you write, you will be able to get a proper breakdown. You can see each word is taken as a token and then it is explained, and then you can see adding the position information and then combining the word and position, and then you are getting the answer. So you don't have to rely on anybody, right? You can easily leverage ChatGPT, but you have to make sure you write it in a way which is understood, because the context or the problem is understood by you, but you have to pass similar information to ChatGPT. Okay, so okay, jumping on to the next topic, which is decoder only architectures. Okay, so what is a large language model? Before getting into decoder only architecture, let me tell you that large language models are, there is a wrong interpretation that large language model is generative AI. No, large language model is not generative AI. Okay, large language models, another speculation is large language models is a decoder only architecture. Again, wrong. So large language models are simply large language models. I mean, they are language models which are trained on billions and trillions of data. Okay, so they are simply transformers trained on large corpus of text data. Simple. Okay, it can be a BERT model, it can be a GPT model. So it can be a encoder only, it can be a decoder only, it can be a encoder decoder both, which is a T5 model, which is a sequence to sequence transformer model. So all of these are large language models. Okay, so large language model is not generative AI, which is a wrong speculation. People think it's generative AI. No, right? Now, what is generative AI? Generative AI is nothing but speculated from GPT, which is nothing but generated pre-trained models. Okay. Now, focus on this word called as pre-trained. Now, in the space of AI, there are two things. Okay. One is pre-trained, one is fine tuning. Okay. So pre-trained is those models that are already trained on huge amount of data. Okay. How many of you know deep learning? Just write down yes or no. If no, then I will not give examples specific to deep learning, else it will not be understood, right? Okay, no issues. So pre-trained models are for everything. In NLP also we have pre-trained models. On deep learning also we have pre-trained models. Okay. So some of the deep learning pre-trained models are, let's say Inception V5, Inception V4, MobileNet. So let me show you deep learning pre-trained models. I'll directly show some examples so that maybe comparison. Yeah, ResNet, SqueezeNet, MobileNet, and these are all some models that are trained by big companies, right? GoogleNet is by Google. ResNet is by some other company. MobileNet, AlexNet. So there are big organizations who have invested a lot in preparing these pre-trained models. And the reason behind preparing a pre-trained model is that tomorrow, if a user or a company wants to work on a problem statement, instead of creating their own architecture, which could be very resource, it will consume a lot of resource, cost will be involved, many things. Instead of that, they can directly use a pre-trained model's brain and feed their own data, which is called as fine tuning. Okay, in simple terms, if you ask me what is a pre-trained model, um, so let's say you, how do I give an example? Okay, so let's say you are this person, okay, and you have this person. So let's say you are A, and this person is B, okay, and this person is very knowledgeable. He has a lot of knowledge on English movies, on politics, news. He has a lot of knowledge. You don't have a lot of knowledge on these political scenarios, right? Now, if you have a question related to, let's say, elections in US, right? Can you go to this person, right? You can go. So basically what you're trying to do is you are trying to go to him and use or leverage his brain. This is called as pre-trained model. Okay. Now fine tuning is when you are leveraging his model and also providing some information from your side to get a better result. That is fine tuning. So in the space of AI, there are already some pre-trained models. Now, in the context of generative AI, I will explain you. Okay, not in the context of deep learning. So let's say GPT. Okay, we'll talk about GPT 4.0. Now, GPT 4.0 is trained on trillions and trillions of data. Okay. Now, what you are doing is you are this person. When you are going to POE or ChatGPT or any online tools, when you're asking something, who is Sachin Tendulkar, write in 2 to 3 lines. Now, what's happening here is you are directly asking the brain, right? So you're directly asking a question, and GPT is responding you with an answer. Fine. But imagine you have your own document. Okay. So here you are leveraging pre-trained model. GPT is already a pre-trained model on trillions of data, right? It has Sachin's information, Sachin's son information, about various other information, news information, sports information, Wikipedia data, stock market data till certain year, maybe 2023. So it has immense amount of data. So if you ask a question, it will answer. So it's basically like you are directly dealing with this model, which is a pre-trained model. Now imagine you have a document. Okay. Now this document is potentially about, let's say, Let's say you have your own research paper. Okay, let's say you have a research paper, or maybe you have your notes from your teacher, PDF notes. What you're doing is you are kind of using this. Along with this, you are creating a better version. When you're asking a question, so let's say as a user you are asking a question, basically you are fetching the answer from this research paper or your notes. Okay, but you are using this model's knowledge to do the chat completion, because for chat completion you need a generative AI model, right? Because ultimately your output is going to be generated. So this is basically you are using your own data. This is called as fine tuning. Okay, and this is what we usually do in industry level problems, because creating a new large language model from scratch is nearly impossible. I mean, for small scale companies it's not possible. For individuals it's like forget about it, right? Big companies who have monetary aspects, I mean, who have money, who have resources, who have GPUs, TPUs, they can invest and work on large language models, right? There are different large language models like GPT 3.5, GPT 4, GPT 4 mini, many options are there. uh, and they have different configurations, different token size, different contextual windows. Llama is there, Mistral is there, different other things are there. But just, if somebody asks you, you can actually talk about some of them. And I'm pretty much sure nobody will ask you, okay, what is the difference between GPT 4o and GPT 4o mini with respect to token size or contextual window? Nobody will ask you these questions, because these are very, questions very specific to that model, right? And as a engineer, as a Gen AI engineer, it's not mandatory to remember those kind of things. It's not needed. But generally speaking, if somebody asks, you can tell, yeah, GPT 4o is definitely better than 4o mini, right? Because 4o mini is a mini version of it, miniature version with less data and less capabilities. So obviously 4o is better. And if somebody asks you about 4o and Llama, which one is better? You can say that Llama is nothing but an open source model, right? So and OpenAI is like a API. So it depends, right? Depends on your use case. So let me quickly give you some ideas on, what are the different type of models, and I'll also tell you about a tabular view which can help you articulate an answer if you get a question related to which models are best, which models are not, right? So in large language models, especially in the field of generative AI, there are different type of models, right? I will divide the models into open source, and I will divide it into APIs. Inside APIs, I will write down private APIs, and I will write down public APIs. Okay. What are some of the open source models? Some of the open source models are Llama 3, Mistral, Mixtral, Zephyr, and many Hugging Face models. Private APIs, I would say that some of the APIs that are exposed by AWS and Azure, let's say AWS Cloud 3, right? So these kind of things which are owned by the private cloud sources. Public APIs are OpenAI, right? You can easily create your account and get started. Now, From an interview point of view, if somebody asks you that for a specific use case, which one would you prefer, right? The general answer is performance wise, it depends. Which one will be giving you better quality of answers? It completely depends on the use case, and we need to hit and trial. But if somebody asks you, okay, what will be your best solution for a proof of concept, and how would you like to see the same application getting deployed in a client premises, right? For a proof of concept, obviously, we should always go ahead with OpenAI. Now, the reason being, it is very freely, like easily accessible. Easily accessible, right? You can just create a API key and done. You can easily access the OpenAI APIs, right? For POCs. Less headache, right? Easy to use, ease of use. Now, talking about if we want to deploy this into a client premises, it depends on what the client asks for, right? If the client is more focused on performance without having something in his mind about monetary aspects, we can go for open source models. But open source models are usually of 8 GB or 16 GB in size, right? They are physical models available online, right? If you go to Hugging Face Llama 3 model download, you can see that this particular model is, what is the size of it? Wait. Somewhere it will be here. You can see 5 GB, right? But there are two tensors, so 10 GB. Similarly, yeah. So the thing is, if the client has no budget issues, they are okay to invest storages either on premises or on cloud, they can go for this option. But this is a expensive option. The easiest option will be OpenAI. Okay. So it depends from client to client based on what the client needs. If the client has no problem about data privacy and all those things, blindly go for OpenAI. If the client has data privacy issues, then also you can go for OpenAI, because OpenAI has clear data privacy policies, no problem. But only if the client requests that, no, I don't want OpenAI, mine is a very critical data, I don't want to take even 1% of risk, I'm okay to spend money, I want models on my premises, then go for this. 16 GB, 24 GB models are also available. Okay. So general idea is this. So the evolution of GPT happened something like this. Like Chat GPT was officially announced in 2022 around, yeah, you can see 2023. Sorry, my bad. 2023 Chat GPT was introduced, and now we have GPT-4. GPT-5 was also released, right? Couple of months back. Publicly, it has not been released, I guess, um, or might have released. I don't have any idea. But all of my models that I'm using right now in my current company or in POCs, it's GPT-4. And even if GPT-5 is released, I will not use it, because when OpenAI releases a new model, it will be very expensive. And eventually, they will make it less expensive going further. So I have not used it. So generative AI, general idea is, it is the generation of text, images, and audios, right? Um, Fundamentals of neural networks are not needed. I'll directly jump into LLMs. So, what are LLMs? LLMs, as I told you, are nothing but large language models, right? They are developed to understand and generate human like data. Now, these large models are trained on vast amount of data and they learn the pattern structures and semantics. They are capable of generating contextually relevant text by understanding the relationships between words and phrases. Okay, so we'll go through prompt engineering in a bit. Um, okay, let's first talk about prompt engineering and then we'll go for RAGs. No problem. Okay, prompt engineering in a nutshell. So what goes into the input of the decoders is nothing but a prompt, right? So there is a way to articulate prompts because the better you write, the better the output will be. As simple as that, right? Now, there are majorly 5 to 6 pointers on what should be a part of the prompt, right? First is context, okay, or topic. Second is tone. Third is formatting. Fourth is or format. Fourth is exemplar or examples. Okay. So what is topic? Topic means the context. What exactly do you need? Right? Now, if I ask you randomly, okay, can you tell me what happened in that high level design that we discussed yesterday? Well, you have no clue about it, right? Because I mean, you are not part of that discussion. Which high level document are you talking about, right? The follow up questions from your side will be which high level document are you talking about? Did we discuss yesterday, right? So, in a human to human level of discussion or uh, language, you know, in a discussion like this, right? If you don't understand, there will be follow up questions, right? But when you are asking a question to generative AI, let's say ChatGPT, now ChatGPT is not a human, right? It's brainless. ChatGPT will still answer you. You can see, I will probably write down. Um, can you explain what are the key areas of the HLD document we discussed? See, see, it is randomly giving me some answers. I mean, it has no context. It is basically giving me random answers, right? So ChatGPT is brainless, right? If I ask you the same question, can you explain what are the key areas of the HLD document we discussed? You will not be able to answer. There will be questions. Sir, which document are you talking about? So, topic is very important, which is nothing but context, right? Tone is important. How do you want ChatGPT to answer? To answer humorously, to answer in a professional way, to answer like a friend, something like that. So, tone is very important. Formatting is also important. How do you want to format? Whether you want bullet points, whether you want, you know, some ending closer points, how? Examples. If you provide examples, it is even better, right? So, let's say I want to ask a question, okay? Write a YouTube script. it is still able to answer on some random topic, which is 5 tips for effective management. Now in this script, nothing is there. There is no topic, only YouTube script, but there is no topic. On which topic, right? I have not defined the format. I have not defined anything. But instead of this, let's say I will give a prompt like this. Write a YouTube script for a topic, introduction to Gen AI or introduction to BERT models. Explain the transformer models, why BERT was created, and different versions of BERT in this script. Start the script with a hook and end the script with a question mark. Try to also include some lines on how should I edit this video. So let's give, what I'm trying to say is I want ideas, and then also I need to edit that video, right? So you can see it's able to explain me. Opening scene, energetic background music fades in. Introduction to BERT models. Hey everyone, have you wondered how machines understand human language? Today we are diving into the most groundbreaking advancements in natural language, right? So this is a very good script, no problem. But can we make it better? Of course we can, because till now, if I am doing a video on this particular topic, there is no introduction about me, right? So what I will do is I will give an example. One of the examples of a script is, have you ever wondered how machine learning works? My name is Satyajit Pattnaik, and I have over 13 years of industrial experience. And today I will be talking about machine learning. This is how usually I start my script. Now let's see. So it is not able to give my name, which is fine, but it has generalized. Have you wondered how machines can understand human language? My name is Satyajit Pattnaik, and I have 13 years of experience in AI and natural language processing. Today I'm excited to introduce you to BERT models and how they're evolved. So you have to write prompts in a proper way, right? Now, prompts are of different types or different structures. Majorly, if somebody asks you how many types of prompts are there, you can tell them there is a zero shot prompting, there is a one shot prompting, and there is a few shot prompting. Okay. Now we will also use ChatGPT to kind of explain. Prompting are of three types: zero shot, one shot, and few shot. Can you explain this with examples? Make it short. I don't want a lengthy answer. So this is for our reference, okay? I mean, this is not a zero shot prompting. Zero shot prompting is basically which has no context. Okay. So it's like translate hello to French. It's a zero shot prompting. No examples are provided, nothing is provided, right? One shot prompting is like you're giving some example. Translate goodbye to French. Example, hello, bonjour, right? Or let's say you want to give something like this. Translate goodbye to, okay, let's say French. Example, hello, okay, something like this. So I'm forcing the answer to be in this format, colon, right? And you can see goodbye in French is colon, au, whatever it is, right? But what is few shot? Few shot means you take more examples, give some more examples, and then ask. So multiple examples are given to help the model understand the task better. Okay. And beyond these type of promptings, there are also few other promptings. Let me also talk about that. So what do you mean by um, chain of thoughts prompting technique, and also tree of thoughts prompting technique? Give me an example of both of them. So there are, okay, my tokens are, we are out of tokens, I guess. Okay, we are back. So, so there are few more techniques apart from zero shot, one shot, and few shot, which is called as COT and TOT. Okay, COT is chain of thoughts, and TOT is tree of thoughts. Okay, so you can see that chain of thoughts prompting technique. This technique involves breaking down a problem into a sequence of logical steps or reasoning. Now, for example, the prompt is calculate the total cost if a book costs this and you buy three books. First, find the cost of book. So basically, you are giving them the steps. First, do this and then do that. Right? So imagine I will try to tweak this, and then instead of this, I will write down one more line that first talk about the transformers. So let's say I tweak it. I should make sure you start with evolution of transformers and how BERT came into picture, and then go ahead and explain the different versions of BERT. Now this is basically your chain of thought, right? You are giving them the input that this is how you need the answer, chain. So one by one by one. Okay. And tree of thoughts is, this technique involves exploring multiple branches of reasoning, alternatives at each step. It encourages the model to consider different possibilities or paths to reach the conclusion. Let's say decide on a vacation destination, considers fact like, so you are asking them to consider different facts and basically creating multiple scenarios. Okay, that is tree of thoughts. What is a tree? Tree is something like this, right? Okay, so what is a tree? Let's say you are trying to see whether you will be interested in a job or not, right? Take the job or not. First you check salary. If salary is less than 20 lakhs, no, I will not take. If the salary is 20 to 40 lakhs, and if it is in Bangalore, yes, I will take it. If it is in Kolkata, no, I will not take it. And then if you know, some other things. So basically, this is how decision tree works, right? This is what a tree is. So if you want a scenario like this, you have to phrase it up like this, like consider these factors based on which create different criterias. That is a tree of thought. Now these are all conceptual things, okay? Only in, I mean, only helpful in interviews. But to write the best prompt, you need not have to blindly follow these techniques. Slowly, your level of writing prompts will automatically be better and better over the period of time. When I started ChatGPT 1.5 years back, I was also writing some, you know, beginner friendly prompts. I was not able to get proper output. But nowadays, I leverage ChatGPT, and trust me, I do a lot of things using ChatGPT. Although you cannot 100% rely on ChatGPT because it's not 100% guaranteed. I use ChatGPT very often because I can validate whether the answers are correct or not. and then only I pass on the information to whatever the task is, right? But you should always validate. You cannot 100% rely. I mean, there are many instances in my life where ChatGPT has given me wrong answers. Now, for example, one of the tasks I was doing in my current company is going through a high level document. So there was a high level document and I was going through it. My work was basically how to validate. You have to check from different sources. So let's say you are asking an academic question, right? Let's say on BERT, or maybe whether Roberta is better than Albert or not, or whether Roberta has how many blocks. ChatGPT says 12 blocks. Go and validate in other research papers or in Google. Try to see different blogs. Then only you can validate, right? There are original creators who have documentations on internet. You can validate from there. Blindly don't believe in ChatGPT. So there are many instances where ChatGPT has failed. Trust me. But in order to be a pro in it, you also need to validate things, and that's how it works. And slowly, when your understanding increases, you will be able to validate. Now, I was going through this document, and my work was basically to give comments on how this design document is. And I already had my comments in my mind. I already started posting. Then I thought, how about basically I have created a project on this also, which will come on the AI Masters program and also on YouTube very shortly. Uh, the idea is I used this document and the statement of work document to create a chatbot where I can ask anything as a like a expert in this domain. So when I asked ChatGPT, can you tell me what are the problems in this document? It was giving some generic answers that this is missing, that is missing, and so on. But eventually, when I gave more information to it, it started learning and then gave me better answers. I when I started creating my comments, I basically gave ChatGPT that, not ChatGPT, my own GPT model, that these are the comments that I have raised. You can see how technically sound these comments are. Similar to this, try to raise some technical comments. Don't raise some random comments on this architecture. And then it was able to give better results. So you just have to, you know, slowly it will happen. It does not happen on the go, right? If you start using ChatGPT quite often, eventually you will be a pro in prompting. There is no need to take any prompt engineering guides or any kind of courses on prompt engineering. There are many books people are distributing on social media, 100 prompts to improve this, 1000 prompts. No need. Just ask more and more questions to ChatGPT, and you will see that in next 2 3 months your way of questioning will also change, and you will automatically understand because the answers will be in a better format. Okay, so we'll quickly try to talk about the RAG architecture, which is the most important thing, and then little bit about vector databases, and I will directly jump into the project. And in the project you will have more understanding, like how things are happening, right? So first of all, before talking about rags, let me tell you a so there will be no break, okay? Just FYI, I don't have time. So if only I'm out of breath, I'll probably take a break, but not like that, okay? So one of the problem is, I also explained this very well in my AI masters program. I mean, some of you are a part of it. You can eventually take my example and take the video and see that. But one of the examples is to understand rags. So let's say I'll go to ChatGPT. Imagine I'm using Vodafone. I'm using Vodafone SIM. I have a postpaid SIM. My monthly fees is like 599. I'm just giving random examples, okay? But my last month bill was around 3999. Okay? And as a customer, I am pissed off. I'll go to ChatGPT. Okay? And I will try to ask ChatGPT. My Vodafone bill for the last month was 399 rupees. Why is it so? Can you please check? As I told you, GPT models or generative models are brainless. Now, when I say brainless, I'm not telling they are bad. What I'm telling is, even if they don't have context, they still give you answers, right? Now, don't treat that I'm telling bad about GPT. Okay, I'm not telling bad about GPT. Simple, right? It is still answering, right? If I ask you the same question, what will be your answer? You will be like, how the hell I will know? I don't know. You must have done some extra calls. I don't know. Why are you asking me? You will tell me the same thing, right? Anybody will tell me the same thing. But GPT is able to give some answers. Well, these are some generic answers, which is fine. But at least it is giving me answers, right? Now, this is a situation where it is called as hallucination. Hallucination is basically a phenomenon in GPT models or in generative AI models where they hallucinate. They do not understand the context properly and then they try to generate some answers which are contextually not right. Okay, that is hallucination. So, one of the problems with generative AI or with GPT models is hallucination. Common problem. The second problem is, okay, I have a research paper. Okay, let's say I have a research paper. Now, of course, this research paper is available on the internet. This is my paper. But just imagine this research paper is not available on the internet, right? So, of course, if it is not available on the internet, GPT will have no idea, right? Now, if I want to ask something from this particular document, can you tell me what is the procedure used in this particular paper? GPT will not be able to answer, right? So GPT will not be able to answer for custom data, right? Now, if you go to Vodafone.com, Idea.com, oh, it's not, sorry, Vodafone Idea, oh, myvi.in. So let's say I go here and then ask the same question. I go to Vodafone and I ask the same question. I'm a customer, right? I can ask, right? I'm asking the same question. What's happening? My Vodafone bill for the last, oh, it didn't even take the full message. Now, as a customer, first of all, the experience is not good, right? Second of all, it is giving me some random results. How do I get help? Now, this is where Vodafone can take an action. What if Vodafone comes with a chatbot? And this chatbot basically can, once you provide some of your information, the chatbot will basically have information about your profile, your usage, your details, which the chatbot can basically fetch from a particular database of Vodafone. And when you are asking a question, the chatbot should be able to answer. If this happens, the customer will be happy, right? Now, instead of this search, I can simply have a chatbot and I can answer. I can get my answers, right? Why my Vodafone bill is not. I'm not talking about somebody coming to the chatbot and answering. I don't need a physical person. I need a bot, complete AI bot, which understands your profile, your more details about you, goes to the database, checks everything, and gives you the answer. And this is where RAG concept is related to. Custom data is very important. Again, in this one, if you want to feed your data to a RAG, to a LLM pipeline, you need to use RAG. What is RAG? RAG is retrieval, augmented generation. One of the most critical topics in generative AI. One of the most important topics. Because if you just keep using ChatGPT, what are you? You are not a developer, you are a consumer, right? Go back to the first class. I told you, right? There are two parts. One is a consumer, one is a developer. It's good to be a consumer, no doubt, but we are in our journey to become a developer, right? We should build products. And how do we build products? Let's say I want to build a chatbot which is pretty much built on my research paper. So whenever I ask something, I should be able to get results or responses from my research paper. Okay, let's say I have a research paper in a PDF format. Okay, I'm passing it very layman's understanding. Let's say I'm passing it to the Gen AI pipeline. Okay, and after that, let's say I'm storing the data somewhere. I will make a database, DB, right? Storing the data, and then after the storing is done, let's say I'm going to create a front end. So I have written down as UI, where this is me. I ask a question. Okay, what is the question? Let's say my question is, what is the methodology? Okay, explain the methodology, explain the paper's methodology in 2 lines. Okay, something like this. That's my question. Now, what needs to be done? Of course, I need to go and search in the database. What is the paper's methodology? These are the most important keywords. I will go and search, and then I will potentially get some output, right? Maybe I will write it down as relevant information, right? After this relevant information is fetched, imagine this relevant information is a like a 5 6 or 10 lines of information, right? But your output is requested in 2 lines, right? So you need to have a proper chat completion, right, as per what you are expecting. So this is where the chat completion is sitting, right? So this data goes here. So this chat completion is nothing but your GPT model, or you can write it down as OpenAI, let's say GPT 4.0 model. So this is a very layman's architecture. And this entire architecture is called as a RAG pipeline. because you are using a custom data. Imagine you are not using a custom data. So you can directly call OpenAI, right? Wow. You can directly call OpenAI, right? You don't need custom data like the way we are calling here, right? Directly. And OpenAI will give you a response. If you are doing this, then that's not called as a RAG pipeline because you are not using a custom data. But if you are using a custom data, it is called as a RAG pipeline. Anybody has any understanding problem here? If not, I will move into the more technical architecture. Any doubts here? Clear? Just give me 1 minute. I'm getting a message from a student that I have missed to invite her in the meeting, which is not good. Just give me 1 second. How did I miss her? Uh, uh, is this person on this call right now, Asha Afrin? No, right? Okay, anyways, moving on. Everything is clear, right? Simple. Now I will explain you the more technical architecture. So I already have the architecture with me so that I don't spend time. Okay, so this is a more technical architecture. Trust me, looks complicated, but it's super easy. I will explain you. Okay, so let me first delete all these boxes. Okay, now what's happening is, why is she creating? Oh, wait, just one second. Sorry guys, let's go for a like 2 minutes break. I'm talking to a student who had a miscommunication. So just give me 2 minutes, I'll be back. Okay, so coming back to the topic. So this is a very generalized RAG flow architecture, okay? And any kind of problem that we are solving is somehow related to this architecture. Okay, so let's say we will take an example. Now, what are the examples of RAG use cases? So one of the examples is, let's say, I'm taking annotations here. So one of the examples is research paper bot, right? That let's say you are a researcher, or somebody who is interested in a research papers, and you are bored with going through the research papers, which is very lengthy, very technical. You want to leverage generative AI to create a chatbot where you can pass your research paper and ask everything about the research paper, right? So one is this one. Another one is AI career coach. So let's say you want to pass your resume, and then you want to create a chatbot where you can ask anything. anything about coaching, like what are the problems in my resume, what are the best skills should I add in the resume, I want to learn this, I want to learn that. So your career coach, right? Number three is, let's say, um, you have a website. Okay, you are basically scraping the website. So imagine you have a bunch of PDFs, the website details, and then from that you are basically creating a chatbot. So when the user comes into the website, they should be able to get all the information in the chatbot. Okay. Another example is, let's say, similarly, another example for a website. Let's say you have a website data. On top of that, you have a Q&A Excel sheet, right? And using this, you want to potentially create a chatbot. So for your users that are coming to your website, they should be able to get answers either from the website or from the Q&A Excel sheet. That is another project idea, right? Another project idea is your coach. Let's say you have a bunch of PDFs like statistics PDFs or machine learning PDFs or deep learning PDFs, and you want to create a chatbot where you can ask questions from the PDFs, right? Now, for this, you can eventually use ChatGPT because all this information might be part of ChatGPT, no doubt about it. But sometimes in PDFs there could be some more information, right? We don't know. That's why if there is a need, you can also work on use cases like this. Another use case I have worked on in my current company is, there was an application called as Bloomberg. So the company was using Bloomberg Chat. They basically gave access to all the chat using APIs. So we basically fetched these APIs, got the data, and using a RAG pipeline, we create a chatbot. So using the chatbot, we were able to get the final output in a structured format. So this is also RAG pipeline. Okay. Now, eventually, what is common in all the problem statements is data, right? Research paper also, you have a data. Career coach also, you have a data. Website scraping, you have data. Website Q&A, you have data. Coach, you have data. Bloomberg chat APIs, you have data, right? So data usually in PDF, Excel, JSON, any kind of format, but data is important, right? Whenever you are um, working in RAG pipelines, right? You always need to do what? You always need to, um, where I was, sorry, I'm getting distracted by multiple messages. uh, when you're working on RAG pipeline, right, you always work on custom data because you are leveraging and training in your generative AI module or your GPT architecture on your own data. Okay, so let's get into this architecture quickly. We still have good amount of time for the project, so nothing to worry about. We are on time. The first is data, right? PDF. When you are passing the PDF, the first thing what happens is PDF is converted into smaller chunks. Okay, smaller documents. So let's say document. From each document, embeddings are created, and these are all your embeddings. Okay, so this is your embedded model. Let's say, imagine this is your word to vector model. Okay, now either you store these embeddings somewhere, maybe in a tensor, or store it in a vector database, or store it in a vector index, but you need to store it somewhere. This is the storage. Okay, you are storing the vector embeddings. Now in parallel universe, you have a UI interface and you are asking some question. Now question is also converted into vectors, and again maybe using the same word to vector model, and then you're basically calling wherever you are storing the original data, you are calling, and then you are getting the relevant information. After you are getting the relevant information, this is your OpenAI, and OpenAI is doing the chat completion, and then you are getting the final output. So I will rub the board. I will try to go down so that I can explain you in my own style. So we have PDF document, right? And for simplicity, understand about this simple example, okay? Research paper bot. Okay, you're potentially working on a chatbot trained on this particular research paper. So you have this PDF document, okay? How many pages does it have? Now, my PDF document has 6 pages, around 5,306 words. Okay, just imagine, okay, you have 6 pages, and let's say 10,000 words. Okay, try to understand. The very first thing is reading the file. Reading the file. Okay, after you read the file, the very immediate process is chunking. And while you create a chunk, you have to define what should be your chunk size. Okay, so there is a concept called as chunk size. Let's say my chunk size is 2000. So can somebody tell me how many chunks will be created? We have 10,000 words and the chunk size is 2000. So how many chunks will be created? 1, 2, how many? 5? Others, what about others? 5 chunks will be created, right? Wrong. Okay, 6 chunks will be created. I will explain you why. Okay, because there is another parameter called as chunk overlap. This is also an parameter. So let's say I'm defining my chunk overlap as 200. Okay, now what is chunk overlap and chunk size? Try to understand in a very simple format. Okay, let's say I'm going to generate write about MS Dhoni in 10 lines. I'm just taking this much, okay? That's it. So, okay. Now this is my, imagine this is my PDF content. Okay. Now, how many words do we have? 1, 2, 3, 4. We will ask. I don't have patience to calculate. 103 words. 103 words. Okay, whatever it is. 103 words are there, right? Imagine my chunk size is 20 and my chunk overlap, let's say, is 5. So what will happen is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That will be a part of my chunk 1. Okay. Then chunk 2 will be, there is an overlap of 5. Okay, so 1, 2, 3, 4, 5. So from here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15, 16, 17, 18, 19, 20. Understood? So this is called as overlap. Okay. Similarly, third will be this. Okay. Similarly, 10,000 words. If you are having a overlap of uh, 200, eventually first chunk will have the first 2,000 words. Second chunk will have the last 200 from first chunk plus the second chunk, right? And similarly it goes on, so eventually you will have 6 chunks. Okay, but doesn't matter how many chunks you have, it's all calculated internally, right? Just for your understanding, I am doing this. Okay, after chunking is done, for each chunk for each chunk the embeddings are created. Okay, embeddings are created. Now these embeddings are potentially getting stored in a database. It could be a tensor. Okay, forget about tensor, no technical terms. Let's say it is a vector database, or else it is a vector index. Okay, where somewhere it is getting stored, right? Now there is a front end somewhere here. So there is a user like me, right? I am asking, okay, can you explain me which database is used in this analysis? Okay, let's say which data set is used, right? Eventually, I'm creating a vector and then I'm referring to this database, right? In this database, there are millions of vector data, millions of it. And here we have just one. So eventually what you are getting is the input vector plus relevant information. Maybe let's say this one, let's say this one. You are getting some relevant information. Okay. And then you are calling the OpenAI model or just the GPT model. And OpenAI model is basically doing the chat completion. And then you are finally getting the output. This is the architecture flow of your generative AI architecture flow. What is your input? Input is this one, no? So you have a front end interface. This is UI, where you are asking a question about your research paper. Tell me about the data set used. And this is also converted into vector. And then we are getting from the vector database or the vector index. Now, what is a vector index and what is a vector database? I will explain you. But apart from these two technical terms, other things are clear. If other
So
things
we
are,
are getting the input from vector database. So what is that input?
where are you getting it from vector database?
You are shown in the diagram of vector input and relevant information.
Input is this one, your prompt. The prompt that you are passing and the relevant information, and you are sending it to OpenAI. Okay. So it's exactly like this. What is happening behind the hoods? Let's say you are passing the input is what is the data set used, and the relevant passage is, let's say, can you give the final output in just 2 lines? So you are passing the input, which is this part, and then you are passing the passage or whatever the relevant information is, which is this from this part, and then you are giving an input that give me answer in 2 lines, and that is nothing but your prompt. This is the prompt template that you are using. Okay, and that is, there is somewhere here, there is a LLM model here, like a LangChain model here, where you are also passing the prompt and using the prompt is also going here, and then you are getting the output, and the output is this that you are receiving on the front end. Okay, I'll, when we jump into the coding part, I will explain you each and everything. Now, what is a vector database and what is a vector index? Vector database is something like, everybody knows about different types of databases, right? We have Oracle SQL databases, we have MySQL databases, we have MS SQL databases, we have Snowflake, we have MongoDB, right? These are all scalar databases. Okay. When you are converting textual data to numerical data, you are basically having vector data, right? And vector data for a huge, like the input is huge, right? So 10,000 words. So imagine the vector data will be very complex and it will be in a format of numbers, right? So there is a need of special database. Scalar databases are not good enough to store vector data. That's why we have separate vector databases. The advantage of vector database is fetching data from vector database is faster. Scalar databases are slow. Oracle, all these are slow databases. Like if you have huge amount of data, they will not work, right? So vector databases are meant for vector data. And one of the examples is Pinecone. You can easily go to Pinecone and learn more about what vector databases are. Okay. Vector database, everything is explained here. This one page will explain you each and everything about vector database. Okay. And what is a vector index? Vector index is nothing but a local vector storage. So whenever you are creating a project, let's say we will be creating a project now, we will be using a vector index. So the index will be stored in my local machine. So let's say this is the project that I will show right now, and you can see the vector index is here. So it's a local storage. Now, if you want to use this chatbot, you need these in your local system, else it will not work, right? But when you are using a vector database is public, right? If I am using a vector database, you can also use the same chatbot because vector database is public. Vector index is a local solution, as simple as that. So there is a concept called as FAISS that we use, which is Facebook AI similarity search. So using vector database, when we will be storing the research data information here, right? Whenever you are sending this input and you're getting this relevant information, right? You're basically getting the relevant information using this concept called as Facebook AI similarity search, FAISS. Many of you might be thinking, right? A vector database, we have the data, but how this relevant information is fetching? There must be some brain, right? Because OpenAI is not here. There must be somebody who is getting this information, right? And that somebody is this. The difference between vector database and vector index is vector databases are meant for production level projects. When you want to use huge amount of data, let's say you have hundreds of custom PDFs, your vector space will be huge, right? Multidimensional, too much of data. In that case, vector index will not work. Vector index is only for a local project, which is sitting on your own computer. That's it. Vector indexes are not recommended for production level projects. Okay. So we always should use a vector database. Vector database examples are Pinecone and Amazon AWS also has vector databases. I think I forgot the name. If I see, I'll remember. Yeah, Open Search is also there. Open Search is there. Yeah, RDS. RDS is there. I have not used MemoryDB, but I think this is new. I think this is Redis MemoryDB. Yeah. So every now and then new things are popping up, right? So it's difficult. But I have used Pinecone a lot. I can also show you Pinecone for one of my projects. Creating a vector index is very simple in Pinecone, vector database index. LangChain is just like a, what do you say? Like, I'll explain you. When I start the coding, I will explain you. It's like a connector. So we have used, so this is a index that we have created in the vector database. Okay. So for one of our demo projects, we have created index and you can see that all these are vector data. And I have used one of the papers, which is RAG paper. I can show you that paper also. This is the project which we have on our AI Masters program, uh, research paper bot. So this research paper we are using in Pinecone, and then you can see like line by line, we are storing the values here. And when you are using vector database, the latency will be better, right? Because um, local index will not be able to store huge amount of data, right? So that's when we use Pinecone vector database. Okay, so that's it. We will jump directly into the project. We have 30 minutes. I'm not sure if 30 minutes is enough, but we'll try our best. So this project anyways is coming live on my YouTube channel very soon. And for those who are part of the AI program, I have also released this project just last night because created it last night just for the sake of workshop, and I have also given the course in the video in the course. So in case you can want to watch it there, you can watch it there. So let me explain you this project. This is a very interesting project based on the principles of my tool. Anybody knows about this Zep resume? This is a new tool that we have created for job seekers. Right now it is free. Till the end of this year, it will be free. Next year, it will be chargeable, but it's not completely chargeable. I don't know about the pricing, but you can explore. So in this tool, there is something called as career coach. Okay. So, what is the background logic of this? I will explain, and then I will go to the project code on how I have created the project code, and eventually I will send you the code to you. Okay, so no worries. Okay, let's go ahead with the project. So, first of all, what is the project all about? Okay, the project is AI career coach. Now, there are few things. Okay. The first thing is that what is the input to this coach, and what exactly this coach is going to do. So forget about the word AI. Who is a career coach? Career coach is somebody who guides you, right? Let's say I can be one of your career coach, right? Now, in order for me to give you some tips, what I need from you, I need resume, right? And resume is more than enough, right? Of course, if you call me and explain me more about your profile, it's good. But eventually, what you are going to tell me over a conversation should mandatorily be present on resume, right? Because you cannot really go and explain everything about yourself to recruiters, right? So you have to pass on all the information on resume. So literally resume is most important for a career coach. Only when you send your resume to me, I will be able to give you some inputs, right? So resume plays a important role. And resume is normally a 3 to 4 page PDF document, right? And assuming we usually have like 400 words in one page, but resumes are having less content, right? So imagine a resume should not have more than 1,000 words. I mean, logically, it should not have. I can check my own resume if you want. How many words do we have? You can see 1,000 words, right? Literally 1,000 words. So 1,000 words are not too much, right? Now, what we need to do here, chunking is needed. Well, in this case, chunking is not needed, but make it a habit. So always make it a habit to get started with chunking. Okay. So chunking basically divides the data into chunks. In this particular example, there will be no chunks, but there will be just one chunk, right? And then after chunking is done, we will be calling a word embeddings, right? And then these embeddings are going to be stored. I'm talking very specific to this project. Okay. These embeddings are going to be stored in a vector index. And I will write it as a local vector index. Okay. Local vector index means on my system, right? Here. And if I delete it, it's fine. It will be created when you start your application. Okay. So local vector index, you have your data. We will have a front end, which is like a chatbot. Okay. When when you are invoking the UI, you will have to pass your resume, right? So basically, I will change this diagram here. So basically, you have a front end and you are uploading your resume, right? And then you are storing it in the vector database. Now, from the vector database, in UI, you have already defined a prompt. Okay. What will be the prompt? The prompt is you are an AI career coach. Given the resume, give me the summary of my resume in below points. Education, experience, blah, 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 right? Projects, skills. Also provide a resume score out of 100 based on, let's say you want to give this, you can also give this. But in this project, I have not provided this thing, but it's something like this. And then you're basically asking it to Your prompt is provided, and then based on this prompt, it's going to this local index, getting all the relevant information. Plus the input. Okay, input is that you are passing, and then you are calling OpenAI, and then you are basically giving the output. This is the flow. Beyond this, in this project, what's there is, on the front end, you also have another chatbot, okay, or like ask a question, where whenever you are asking a question, let's say, let's say, can you rephrase, or let's say, I want to move into XYZ domain. Tell me how to do it. Now, this is the question that you have passed, okay? Now, this question goes directly to OpenAI, or maybe here, okay? Another flow starts here, relevant information plus input, another flow, and then this output goes to the chatbot. So it's little bit complicated because there are two processes in this project, but overall is it's this, okay? I'll explain once again. And once I show you the application, you will be able to understand. So the application is already on AWS. I just deployed it yesterday, because on local machine I cannot show you. On local machine I cannot show you because I am staying in Hong Kong, right? In Hong Kong, OpenAI is banned. That's why I cannot show you on my local machine. So I'll potentially show you here. Okay, so this is how your application front end is. Okay, so now you are here. This is your UI. This is your UI. Okay, first you are uploading your resume. Okay, so now you are in this step. Let me do it in red. Now you are here. Okay, now you are uploading your resume and clicking on submit. In the background, what's happening is chunking is happening, word embeddings is happening, and data is stored in local vector database. Okay, as in this case, the application is deployed on AWS. The local vector index is created in the AWS EC2 instance. Okay, and then you are able to get a final output. Okay, that uh, he is a seasoned lead data consultant with 13 years of experience. And how am I getting in this format is how I have defined my prompt. Okay, so I have basically defined my prompt in a way that you are a career coach, given the resume, give me the summary. So it's not education experience, it's like uh, career objectives, and then skills and expertise, and so on. Okay, I'm not elaborating. So this is what I have passed in the code, based on which I am able to get the response here in this format. So now you are where? Resume is passed, chunking is done, word embeddings are created, local index is created. Then you got the relevant information along with this. So let's say this is x1. So here you are getting x1 plus all the relevant information. So let's say r1. and then you are calling the OpenAI, and OpenAI is giving you the output, and you are passing it to the front end. So this is it. Now the second flow is ask a question. That is the second flow. So you have a chatbot, ask a question. Now let's say you are asking a question. I want to move into AI architect roles. What changes I need in the resume? So I will change this question to like this. Okay. Now this is my question. Now what is my input to? So let's say this is x2. And for this input and the resume, let's say the relevant information is R2. So you're getting x2 plus R2. You're calling OpenAI and giving the final output. And this is output. To transition into AI architect role, you should focus on highlighting relevant skills, experiences, and project that align the responsibilities of an AI. See, don't worry about formatting. Formatting is something which is a UI skill, right? It is not a generative AI skill. It's a front end skill, right? And I'm not a front end person. So that's why it's not formatted. But yeah, if we format it, it will look better, right? But you're able to see, right? It's answering. It is mentioning that highlight your relevant skills, emphasize skills related to AI architecture, system design, cloud architecture, integration, cloud platforms, AI frameworks, tools like TensorFlow, PyTorch, emphasize your leadership qualities. So it's actually giving a good response. Let's say I want to ask another question. Now what will happen? You're basically invoking again this one. And now let's say you ask another question, that will be x3, right? So you will get another answer which will be x3 plus r3, and you will get the output, right? As simple as that. So can you rephrase, let's say I want to move. So this window could have been more better, but yeah, as I told you, I'm not a pro in front end skills. So with whatever I could, I created this. Gain expertise in Power BI by mastering its advanced functionalities and data visualization and develop leadership, right? So something like this. You can always test it out and tweak the code, no worries. But architecture wise, everything is good. If yes, I'll go into the code and I will do a code walkthrough. So far, so good. Enjoying the project.
The first case, the prompt was fixed.
Sorry.
Like in the first case, the prompt is fixed. You
Yeah,
fix
this
the
is a
prompt.
fixed prompt. Yes, this is a
Okay.
fixed prompt that you have already written in the code. I will show you that. And this is a prompt that you are passing from the front end. Okay. So let me quickly open it in the in my spider, and then I'll show you. Okay. So these are all imports. Okay. Now LangChain, as I told you, LangChain is nothing but it's like a connector. Okay. And it's like it connects the language model with the code, Python code, as simple as that. And using LangChain library, you can actually use the LangChain. So LangChain is a library which provides a lot of things. It provides the connector to the OpenAI. It provides the chain on how you are building the pipeline. It provides the prompt template. It provides the embeddings, a lot of things. Okay, it's like a framework. Okay. So first line is very simple. We are importing Flask. Second is OS library, which is for working on operating systems. This one I think it's for, yeah, secure file name while working on file names to make it secure. PyPDF2 is for parsing the PDFs, and LangChain is a framework for doing everything with respect to the language model. Okay. The first piece of code is very simple. I'm calling a character text splitter, and this is where I'm defining the chunk size. You remember, right? I told you chunk size and chunk overlap. This is the same thing. Chunk size and chunk overlap. So I'm creating the text splitter. So whenever you will be passing the document, you will be first reading the file, right? And then you will be doing the splitter, and this is the chunking part. Okay. Then I have defined my embeddings. So here we have studied about Word2Vector, about bag of words. There are many Hugging Face embeddings also. So here I'm using a Hugging Face embedding from LangChain embeddings. Okay. If you go to LangChain embeddings, there are hundreds and hundreds of embeddings. There are many embedding models. Okay. So you can potentially check all of these embedding models. You can see Vertex AI embedding is there, Azure OpenAI embeddings are there, Hugging Face embeddings are there, multiple embeddings are there. Okay. Going back. So here, this is the part where we are kind of creating the vector index. Okay. I'm calling the FAISS library. What is FAISS? FAISS is Facebook AI Similarity Search. It's a library for efficient similarity search and clustering of dense vectors. Okay. If you go back to the if I go back to the Miro board, right? Here, the fetching part, the relevant information part, that is done by the FAISS. So whenever you use your data, first you create an index. From that index, you are basically calling a retriever. And based on a similarity search algorithm, you are calling the retriever, right? And you are creating a retrieval QA from chain type. Here you are passing the LLM, you are passing the chain type, you are passing the retriever, and whatever response you are getting, you are storing it in result. So this is a method that we have created. Here I am initiating the Flask application. I have mentioned my upload folder, which is uploads. So whatever you upload will be stored here. Okay. If you upload 10 resumes in 10 trials, this folder will have those files. Okay. So here is the extraction part. Extract text from PDF. Here I have defined the chat GPT, chat OpenAI part. Model I'm using 4.0. Temperature is 0 for no variations. This is where you need to add API key. You can take it from the front end OpenAI platform. And this is the fixed template that I'm using. Okay. This is the exact same thing that I explained you, right? So this part, this is it. This is my summary template. Now here I'm calling a prompt template. I'm passing the summary template. Now if I go back to the Flask application, these are Flask routing techniques. For those who does not understand Flask, there is no way I can explain you right now, because as I told you, Python is needed, right? Even if you don't know Flask, you will still be able to understand. There is a Flask end-to-end video on my channel. It's a 30 minutes video. Just search Flask Satyajit or something, you will get it. You can go through that to understand more about Flask, and then you will be able to understand this code. But if you don't understand Python, I cannot help. Python is mandatory, right? So these are routing techniques of Flask, which basically means when the Flask application will be turned on, the first HTML that will be rendered is index.html, which is nothing but this one. So when the application is turned on, we will be able to see this page. When you are clicking on submit, so let's say I'm going to the home page. When you are clicking on submit, right? This is where the upload button is clicked, post method. Here you are basically redirecting the URL for index, and then you are reading the file. Here you are reading the file in the secure thing and then uploading it in the upload folder. Here you are calling the extract text function, where you are using the PyPDF2 library to read the file, and after that you are calling the text splitter, where you are splitting the file. And you can see line by line everything is mentioned, right? First extract text, then text splitter, then you are calling the FAISS from text. Then this is where you are storing the vector index, the local vector index that you are storing. Okay. And then you are calling the resume analysis chain, which is nothing but the LLM chain, where you are calling the LLM and you have passed the resume prompt, which is nothing but your summary prompt, right? It's very easy. If you backtrace, you will be able to understand everything. And then after that, you are rendering the results.html. What is results.html? It is this one, your resume analysis results, right? The analysis results that you saw initially, that page. Slash ask is nothing but this one, when you are asking a question. So when you are clicking on this, basically it is redirecting it to slash ask. Okay. And when this is called, then you are basically calling this function perform QA. And in this perform QA, you are basically calling the large language model to get the most relevant information. So there is no internal prompt here, but the prompt, whatever you are passing from the front end, you are basically getting the front end prompt, right? Query. This is the same thing that you are passing from the front end. Okay. And then you are passing it, and then you are invoking the retrieval QA, and you are getting the result. That's it. And then you're starting the main function. So how to start this application is very simple. When I pass you this code to you, simply what you need to do is first go to that folder. Okay. First install these requirements. So to install requirements, I think everybody should be able to know pip install, right? I will not run this, or else individually you can install, and then simply just go to python app.py. That's it. So it will take some time for the very first time, and within couple of seconds your application will be ready. Done. Application is ready. It is running on this. Okay. So we will go and we will open localhost blah blah blah. Oh, somehow it has restarted. Anyways, it will be on very soon. Mm. It is taking so much time. FAISS is the similarity algorithm to get the relevant information from the vector database. Hmm. Okay. So the application is up, and I cannot show how it works here because it will fail, because I'm in Hong Kong, and then even okay, this is where you need to pass your API key. Okay, make sure you pass the key here. Where is this? Where is this? Where is this? Yeah, this part. I have not passed my key, right? Uh, so that's why whatever I do, it will fail. It will fail with an error that key is not right or something. I don't know. But this application is running. I have already deployed on AWS EC2. I just showed you, right? It's working. So it's throwing me this error because I'm in Hong Kong. But yeah, for you, it will work. My deployed application is working. So, okay, I think that's all about it. I'll keep the call open for few more minutes. In case you have any questions, you can ask me. Where to get API key? Chat, OpenAI platform. Okay, that's all about this entire workshop. It was quick, but I believe a lot of information was passed on to you. Now you know what should be your next things to learn. Of course, mastery in NLP and deep learning is not needed, but I was not able to explain you the internal architecture of transformers, because the internal architecture of transformers and BERT is eventually a neural network, and you don't know machine learning, right? So it will be difficult if I just go and explain it. You will not be able to understand. So that's why, to become a developer, you know, same thing, machine learning and deep learning is needed, but not to that extent. Even if you don't understand ML and DL, you'll still be able to create a generative AI project like this, right? Because here you are not actually creating a neural networks. Neural networks is happening in the background. You don't need to understand transformers internal architecture to work on this project, right? But it's always good if you learn those things. So yeah, that's all about it. I mean, people who are already a part of my AI program, you can always check in-depth videos are already provided in that program. Transformers, NLP explained in a very layman's term. But for others, there is no mandatory. But yeah, in case you want to explore my program, you can reach out to me. I will help you out. Can you recommend book on ML? I don't recommend any books. Sorry. Because I'm myself, I don't read books. So I read blogs, and I read research papers. I don't read books. So I'm not the right person to tell. Tips for getting a job for AI engineer or Gen AI or data scientist or similar role. Um, Sorry, it's not Sashank, it's Satyajit. But anyways, tips for getting a job for AI engineering role. Um, I mean, as a fresher or as an experienced professional? See, as a fresher, you should be open on everything, right? The more openness you have, the more chances you get a job. And portfolio projects very important for freshers. Very important. Like, I don't even spend more than 2 seconds in going through the resumes whenever I hire an intern or even for a fresher opportunity. 2 seconds, that's it. And if I see some random easy projects, it doesn't attract me. For experienced professionals, background is very important, from which background you are coming from, because you will be eventually using your experience to migrate into this data science and AI area. So the most important thing is go and talk to your, in case you are completely isolated, you don't know what your data AI team does, then go start build relationships with them, talk to them, understand what are the business problems that they are solving, right? And then try to be picky on the projects, because you already know what your company is solving, right? After that, start picking the projects wisely, and then start thinking what type of projects are important, especially for your background, and then work on those projects, as simple as that. But learning wise, I think for data science and AI, the domain is not that simple right now, because there are a lot of requirements, a lot of expectations from companies. 5 6 years back it was very easy. When I transitioned, honestly speaking, 8 years back, just machine learning was enough. I did not knew deep learning. I learned deep learning, I learned few other things on the go. But now, if somebody who only knows machine learning goes for an interview, they will be bashed, right? Because expectations are huge right now, so you should be aware of everything. And in order to learn everything, starting from Python, stat, SQL, ML, DL, machine learning, sorry, NLP, transformers, deep learning, computer vision, there is good amount of time that you need to invest. Okay, so agents are something like, they help you in automations. AI agents, it's like you want to automate some processes in your company, right? For example, your company wants to take, let's say I was giving the Bloomberg example, right? So in that project we are actually using agents. That's a real project actually. In one of my client companies, we are, they are basically using Bloomberg. So the project is something like this. So they have Bloomberg. Bloomberg is basically a tool, like a chat tool, where their agents are talking, okay? Like customer service. Imagine customer service. And then from this interpretation, they basically get to know few details, like the product details. What is the product they are talking about? What is the customer sentiment, whether he's interested or not? What is the cost of the product? Something like that. And the project is, we have to automate this process to store data from the chat in a structured Excel format and eventually push it to a database. So here we have used generative AI. So after we extracted that, we have automated the flows for chat extraction. And what we have done is, the chats are automatically extracted using agents. And then we are calling, imagine something is here where we have the GPT architecture, and here we have, it's basically doing all the work, extraction of structured, unstructured to structured data and all those things, formatting, and then it is basically sending it to Excel. And this is happening on a, on a daily basis. So agents are basically, automations, that's it. Okay, what are the best practices or best projects for fresher to secure data scientist and ML? I mean, these days nobody's using ML. Trust me. You need to have projects, especially ML is now a part of data analytics. To be very honest, like in data analytics, companies are expecting you to have predictive analytics knowledge. So um, ML projects, if you don't write ML projects, better go for NLP projects or maybe Gen AI projects. So maybe some projects where you can mention BERT, maybe try out BERT, Albert, different models, see which one is working for text summarization or translation, and pick that project and then write it down. Generative AI, try to open up your mind, explore some of the use cases. Uh, there are many generative AI project ideas like AI insurance claim prediction, this project that I told you. So you have to do your own research and start working on projects, but it should be like a RAG project, RAG pipeline project, and then write it down. ML projects not recommended. Sumit, it's a process. You cannot really, there is no platform to learn about AI agents. Like it's just a concept, right? So it's like just a automation concept to do some tasks. So there is no such tool to learn. Eventually, once you start working on non-agent ways like proof of concepts, and then eventually you will understand more about AI agents. Okay, that's all about it. Thank you all for being a part of this session. I hope it was fruitful. In case you have any other questions, let me know in the WhatsApp group. We will plan to come up with some other workshops as well, especially for people in this group. As you are already aware of certain extent, maybe we'll have like another workshop only specific to projects where I can go deep into Llama architectures and Mistral architectures, and probably take a project and compare different models, which will be like the second version of this workshop. But I need to still think what can I do, but that will be only catered to you guys. That's it, not for everyone, because else everyone will be like, oh, I don't understand this, why this guy is starting explaining this thing, right? Only for this group we'll plan, but only again the prerequisite is only if we have 10-15 students, right? Else it's a waste of time for me. And yeah, I'm planning to have other sessions as well in other areas, like I'm planning to have a session on AWS tools, on Azure tools, to understand more about Azure AI services, these kind of things. I'll probably send you some information once we finalize. But yeah, thank you for your time. I hope you enjoyed it. There will be an anonymous survey sent to you. Names will not be provided. Just give honest feedback on how I could have improvised, and do not blindly give negative comments. Think about all the aspects. The time was short. Monetary aspects also, it was not a huge ask. So think about everything and give genuine feedbacks. So yeah, I'll send you the feedback link in the group. Okay. Yeah, for sure, Karthik. 2 weeks, definitely. Not even 2 weeks. Like it will be more than 3 to 4 weeks because I'm traveling next week, and it's Christmas, right? So December end, not possible. Maybe January, mid-January or something. Okay. Thank you all. Please practice as much as possible. The code project will be provided to you. The project codes will be provided to you as part of the GitHub link. That's it. Any questions? Feel free to ask me on the group. Thank you. Bye bye.